How did builders in the 1200s guarantee their soaring Gothic arches wouldn't crumble under immense pressure? It all started at the quarry, where the wrong choice meant certain architectural disaster. We are tracing the meticulous process of sorting every individual stone to ensure it could withstand the relentless force of time. Welcome back, traveler, to Boring History, a quiet corner of the world where we leave behind the noise of today and gently wander into the stillness of the past. Here, the fires of history burn low and steady, casting long shadows over forgotten stories. We are not here for kings and conquests, but for the quiet, strange, and sometimes unsettling moments that time nearly buried. Before you get comfy, go ahead and like the video and subscribe, only if you're actually enjoying it. Tell me in the comments where you're watching from and what time it is for you. I'm always curious to see the mix of places and time zones hanging out here together. The vision. In the year of our Lord 1140, there came to the Abbey of Saint-Denis, a few miles north of the walls of Paris, a man of singular purpose and uncommon imagination. His name was Suger, and he was the abbot of that ancient monastery, a small man, by all accounts, slight of frame and plain of face. Born of humble parentage, at a time when the church was the only institution that might lift a man of talent from obscurity and set him among the powerful. He had entered the abbey as a child, oblate, given by his family to God and to the Benedictine order, and he had risen through its ranks by virtue of a mind that combined fierce practicality with something rarer, an almost aching sensitivity to beauty, and a conviction that beauty was not vanity but theology, that the loveliness of crafted things was itself an argument about the nature of the divine. He had been a royal councillor, a regent of France, an administrator of considerable ability. But what he carried within his breast, through all the years of political negotiation and ecclesiastical management, was a dream so vast and so precise that it seemed to belong not to mortal ambition but to God himself. He wished to build a house for the Almighty, unlike any the world had yet seen. The Abbey Church of Saint-Denis was already ancient when Suger was born. It stood upon ground sanctified by the legend of Saint Denis himself, the first bishop of Paris, who had, according to pious tradition, been decapitated by Roman persecutors on the hill of Montmartre, and had then walked, carrying his severed head in his hands, to the very spot where the abbey now stood, and there expired. The church that marked this spot had been rebuilt and extended many times over the centuries, and by Suger's day it was a considerable structure, a place of immense spiritual prestige as the burial church of the kings of France. But it was also dark and cramped and insufficient for the crowds that pressed into it on feast days. Suger described, in his own memoirs, written with a candor and self-regard that would not have seemed out of place in a later, more secular age, how the congregation on great occasions was so dense and so fevered that women were passed overhead above the heads of the crowd to prevent them being crushed. The church was too small for its purpose, and its purpose was nothing less than the glory of God and the dignity of the French monarchy. But Suger's ambition was not merely practical. He was not simply a builder seeking more floor space. He was a theologian of light. He had been deeply formed by a body of mystical writing attributed, in his time, to the Areopagite, to Dionysius, the disciple whom St. Paul had converted in Athens, though we know now that these texts were written several centuries later by an unknown Syrian monk. These writings, which circulated under the authority of that apostolic name, elaborated a theology in which light was the primary metaphor for the divine. God was light. The soul's ascent toward God was an ascent toward greater and greater luminosity. Material beauty, the gleam of gold, the brilliance of gems, the radiance that passed through colored glass, was not a distraction from the spiritual, but a ladder toward it. The eye, drawn by loveliness, was trained upward. The soul, following the eye, rose. Beauty was not an ornament to worship. It was itself an act of worship, a form of prayer conducted in stone and glass and gold. Suger wrote, in words that became the manifesto of a new architecture, that he wanted his congregation, standing inside his rebuilt church, to feel transported from this inferior world to that higher world. He wanted the building itself to perform a kind of theological work, to so overwhelm the senses with beauty and with light that the ordinary categories of earthly existence would fall away, and the worshipper would stand, dazzled and undone, at the threshold of something that could not be named but could be felt. This was a program of extraordinary ambition. It required not merely good stonework and adequate funds, which Suger spent considerable effort in accumulating, diverting tithes and rents and royal gifts into a treasury dedicated to the rebuilding. It required a new way of thinking about what a building could be, the abbey church that Suger rebuilt, beginning with the west facade, and then, crucially, with the new choir at the east end, consecrated in June of 1144, was not a complete invention. Its individual elements had precursors and parallels across northern France and in Normandy and in England, where the Normans had been building great churches since the previous century. The pointed arch had appeared before, the ribbed vault had been used before. The ambulatory with radiating chapels was not new, but at Saint-Denis, for the first time, these elements were brought together in a way that was more than the sum of its parts. The new choir was flooded with light from enormous windows that filled the walls between the slender columns of the ambulatory. The ribs of the vault sprang from their piers with a lightness and elegance that earlier vaults had not achieved. The whole effect was of a space that seemed to dissolve the boundary between interior and exterior, between the stone structure and the light that poured through it, between the material and the immaterial. When the choir was consecrated, in a ceremony attended by the King of France and an assembly of bishops and abbots from across the realm, the effect upon those present was evidently overwhelming. Suger described it himself, using the language of the mystical theology that had guided his vision. He wrote of being transported, as if to some strange region between earth and heaven. The prelates who saw it carried the idea back to their own diocese. The age of Gothic had begun, though no one yet had a name for what had happened. The word Gothic itself would come centuries later, coined by Renaissance critics who meant it as an insult, a reference to the Goths, the barbarians who had destroyed the civilization of Rome. By then, the cathedrals those critics dismissed were already monuments, already ancient, already worked into the spiritual landscape of Europe, so completely that it was impossible to imagine the medieval world without them. What is most remarkable about the vision that Suger embodied and set loose upon the world is not that it was theological, for all medieval architecture was theological in some sense. It is not even that it was ambitious, for ambition had always driven men to build. What is remarkable is that it was simultaneously utterly spiritual and utterly technical. Suger wanted something that had never existed. To get it, his builders had to solve problems that had never been solved. The desire for walls of light, for a church interior in which the stone structure seemed to float, unsupported, in a luminous haze of colored glass, was not merely a poetic aspiration. It was an engineering problem of considerable difficulty. How do you make a stone building that seems to have no solid walls? How do you hold up a vault of stone 60 feet above the floor, without walls thick enough to block the light? How do you let in the light, without letting in the forces that would tear the building apart? These questions would occupy the builders of Gothic cathedrals for the next 3 centuries and more. They would be answered over and over again, in stone and mortar and lead and glass, in the great churches of Chartres and Reims and Amiens and Cologne, in the soaring nave of Beauvais that rose so high and so thin that it collapsed twice and had to be rebuilt and reinforced, as if the builders were testing the absolute limit of what stone could do. The answers were found not in universities or in books, for there was then no science of structural engineering, no mathematics of forces and moments and stresses, but in practice, in the accumulated experience of builders who learned from their predecessors' successes and from one another's failures. The cathedrals were not designed in the modern sense. They grew, organically, from a tradition of practice, pushed always forward by the theological imperative that Suger had articulated, and that subsequent generations of bishops and abbots and kings felt as a spiritual obligation, to build, and to build ever more beautifully, ever more ambitiously, in honor of the God who was himself a kind of light. The vision, then, was not merely Suger's. It spread and transformed and intensified with each decade. By the middle of the 12th century, the new style was everywhere in northern France. By the end of the century, it had crossed the Channel and appeared in Canterbury and Lincoln. By the 13th century, it had reached the Rhineland and the Iberian Peninsula. Each region interpreted it differently, the English preferring long, low, horizontal compositions, the French driving always upward, competing from city to city for the tallest nave, the thinnest walls, the most daring vault. But all of them, in their different ways, were attempting to do what Suger had first articulated, to build a threshold between the world of matter and the world of spirit, to make of stone and glass a doorway to the divine. The man who had stood in the choir of Saint-Denis in 1144, dazzled and transported, could not have imagined Chartres. He could not have imagined Amiens or Salisbury, or the Sainte-Chapelle. That astonishing jewel box of a building in Paris, where the stone has been reduced almost to nothing, and the walls are almost entirely glass. 15 windows each, 60 feet tall, filled with over 1,000 scenes from scripture rendered in glass, so richly colored it seems to burn. But all of these were his children, constructed stone by the hands of men, whose names we mostly do not know, in stone by stone by stone by stone by stone lines, watching the light move across the ancient stone, we most again may but can only be stating by being by in the state common with the standing sound with the sickings, but listen with the simil, sixen in, qualikin, wilkin, with in, on, with for, bin, ha, we have at usa, without my tap with a back, a tap, glaus, was scope out the falca, with a spot that with a pen sports board, west, this west, feeling the inexplicable sensation that the ceiling above you is not a ceiling at all, but the beginning of something else, something that goes on and on and on beyond all measurement. This, then, was the vision, not a plan, not a blueprint, not an architectural manifesto in the modern sense, but a feeling rendered in stone, a desire so powerful that it reshaped the built world of an entire civilization, a dream dreamed by a small, ambitious, beauty-ravished abbot in a monastery north of Paris, who wanted to let the light in, and who did not know, could not have known, that in doing so he was opening a door through which the whole of medieval Europe would walk, astonished and undone, for the next 300 years. 2. The choosing of the ground. Before the first stone was struck from the quarry, before the first line was scratched upon the plaster of the tracing house floor, before the bishop came in his robes to bless the endeavor and drive the ceremonial first stake into the earth, there was a man walking. He walked slowly, in no apparent hurry, crossing and recrossing the ground that had been proposed for the new building. He was the master builder, the magister operis, master of works, sometimes called the architect, though that Latin word in the medieval period carried none of the precise modern meaning it would later acquire, and simply denoted a chief builder, a man who directed others. He was, in most cases, a mason by training, risen through the ranks of a craft that was among the most demanding and most respected of the medieval trades. He was also, in ways that we find difficult to categorize according to our own neat divisions of knowledge, a geometer, a logistician, an artist, a structural engineer, and not least, a reader of ground. He walked the site for days, and in some cases for weeks. He was not merely inspecting it in a casual sense. He was, in the most serious and methodical way available to him, without modern instruments, interrogating it. He observed how water moved across the surface after rain, following every small channel and depression, noting where it pooled and where it drained freely. Standing water told him about the permeability of the subsoil and about the lie of the land, and both of these things mattered enormously for a building whose foundation would have to carry forces of many thousands of tons for centuries without significant movement. He tested the soil with probes, wooden rods, iron-tipped stakes, driving them into the earth at intervals across the proposed footprint of the building, feeling for the resistance of hard subsoil, or the sudden give of soft clay, or the clatter of encounter with buried stone. Some master builders were said to press their ears to the ground and listen, not merely in the mystical sense, but because the transmission of sound through soil tells an experienced practitioner something about its composition and density. He was looking for something very specific, ground that was trustworthy over centuries, not merely firm in the sense of bearing a man's weight, nor even firm in the sense of supporting a modest timber house, but firm in the sense that it would not compress or shift or heave under the colossal and uneven loads that a cathedral would impose upon it. The loads were not uniform. A cathedral was not a simple box of even weight. The vaults concentrated their thrust at the piers, and the piers drove enormous vertical loads into the earth at specific points, while the sections of wall between them carried relatively little. The flying buttresses added lateral components, forces pushing outward and downward at the outer pier foundations. The crossing tower, where nave and transept met and a tower often rose above, concentrated enormous weight at 4 specific points. The master builder understood these distributions of force with an intuition built from years of observation and practice, even though he possessed no mathematical framework for calculating them in the way a modern engineer would. He felt the building in his mind before it existed, understood its weight and its push and its pull, and he chose his ground accordingly. The worst enemy of a great stone building is differential settlement, the tendency of a structure to sink unevenly as the soil beneath it compresses under load. Even very small differences in settlement, of an inch or two over a span of years, could open cracks in the masonry, distort the geometry of arches and vaults, and in extreme cases cause catastrophic failure. The medieval builders had no way to calculate settlement in advance, no soil mechanics, no consolidation theory, no way of predicting precisely how a given soil under a given load would behave over decades. What they had was observation and tradition and the accumulated memory of disasters. They knew, from the buildings that had failed around them, what conditions to avoid. They knew that clay soils shrank in drought and swelled in wet, and that this cyclical movement was lethal to masonry. They knew that ground near rivers was often soft and treacherous with waterlogged silt. They knew that the rubble fill of earlier structures, earlier buildings demolished to make way for the new cathedral, could be unpredictable, settling unevenly as the organic material within it rotted away. They sought bedrock where they could find it, or at least stiff gravel or compacted sand, ground that would behave consistently, that would compress under the initial load, and then hold firm for the centuries to come.
When a suitable site had been found, or, more often, when a site had been imposed by history and circumstance. Since cathedrals almost invariably rose upon the foundations of earlier churches, and the master builder's task was then not to choose the ground freely, but to understand the ground he had been given, and to design accordingly, the work of laying out the plan began. This was one of the most solemn and precise operations of the entire building process. The master builder established a baseline, a single straight line from which all the other dimensions of the building would be derived. He used long cords of twisted fiber, stretched tight between wooden stakes driven into the ground, to establish this line with as much precision as his instruments allowed, sighting along it and adjusting until it was as true as he could make it. From this baseline, using the geometric methods that were the core of his professional knowledge, he laid out the entire footprint of the building. The geometry he used was elegant and entirely practical. With a chord of known length and 2 fixed points, a man can construct a perfect right angle. The Pythagorean relationship of 3, 4, and 5, or 5, 12, and 13, was known and used by medieval builders long before most of them had heard the name Pythagoras. With right angles and a standard unit of measure, the entire complex geometry of the cathedral plan could be set out upon the earth. The nave, the aisles, the transept, the choir, the ambulatory, the radiating chapels. The master builder did not need to transfer his plan from a drawing. In the early centuries of Gothic building, plans drawn on parchment were rare and not always trusted, being subject to errors of scaling. He worked directly in the landscape, with cord and stake and the geometry in his head, and the building took its shape upon the ground in a process that was simultaneously abstract and utterly physical. The trenches for the foundations were dug to depths that varied depending on the quality of the subsoil. Where bedrock lay close to the surface, the trench might be shallow, only a few feet below grade. Where the soil was soft, or where the builders had reason to distrust what lay beneath, the trenches might go down 10, 15, 20 feet, filled with rubble and mortar until a solid platform had been constructed from which the walls could rise. The labor of digging was enormous. It was done entirely by hand, by men with spades and picks and the simple machines of their age. Wheelbarrows and wicker baskets and wooden pulleys operated by hand or by the treadmill of a great wheel. Thousands of cubic feet of earth were moved in the foundation work of a major cathedral. The spoil was used to level the building site, to raise ground levels, to fill in the areas between the foundation trenches, consolidating the entire footprint of the building into a single raised platform of tamped earth and rubble. In cities, the work was complicated by the presence of earlier structures and earlier lives. The ground beneath a medieval cathedral was almost always layered with history, Roman remains, earlier medieval construction, the graves of the pious dead who had been buried in the precursor churches on that spot for generations. The bones of the dead presented not merely a logistical challenge, but a spiritual and legal one. They had to be moved with ceremony and reverence, reinterred in consecrated ground elsewhere, their disturbance acknowledged and prayed over. The master builder, for all his practical orientation, worked within a world saturated with spiritual meaning, and the ground he built upon was never simply ground. It was memory, it was sanctity, it was the accumulated weight of human devotion, going back sometimes for centuries before the cathedral rose above it. When the foundations were finally complete, when the rubble had been packed, and the mortar had cured, and the upper surface had been leveled and checked, the master builder would sometimes order that the entire foundation be left to settle for a season. or even for a year, before the walls above it were begun. This patience was hard won. There was always pressure from bishops and patrons to begin the visible work, the work that could be seen and admired and shown to donors as evidence of progress. But the master builder understood that haste at this stage was the most dangerous economy of all. A foundation that had not settled fully before the walls were raised would continue to move after they were up, and the consequences could be catastrophic. He stood firm against whatever pressure was brought to bear, because he understood, in his bones, in his experience, in the inherited wisdom of his craft, that a cathedral was only as good as the ground it stood upon, and the ground had to be trusted before anything else could be trusted. The patience required to choose the ground, to read it, to lay the foundations and let them rest, this patience was itself a form of faith. It was the faith that what was being built would last, and that its lasting mattered more than the urgency of any single bishop or the impatience of any single generation. 3. The quarrymen. Long before the cathedral began to take its shape against the sky, long before the first course of dressed stone appeared above the level of the surrounding ground, long before any passerby could stand at the edge of the building site and begin to imagine what the finished structure might look like, there were men working in darkness. They were the quarrymen, and their labor was the most fundamental of all the labors that the cathedral required. For without stone there was nothing. No walls, no piers, no arches, no vaults, no spires. The quarryman came before the mason, and before the architect, and before the bishop who commissioned the work. He came before everything, descending into the earth, while others were still dreaming of what would rise from it. The great limestone quarries of northern France were among the most important industrial sites of the medieval world, though they would not have been recognized as industrial in any modern sense. They were places of extraordinary physical labor, conducted underground in conditions of poor light and constant damp, by men who had inherited their trade from their fathers and would pass it to their sons, who knew the rock intimately, its grain and its bedding planes and its faults and its tendency to split along certain lines and resist along others, with the kind of knowledge that only comes from decades of daily contact. The finest limestone for building came from a number of specific sources. The quarries around Caen in Normandy, in the region that the Normans had ruled and enriched before the conquest, produced a pale, fine-grained stone of extraordinary quality, creamy white, dense, resistant to frost and to the slow dissolution of rainwater, easy to cut and carve when freshly quarried, but hardening with exposure to air. This Caen stone crossed the Channel to build Canterbury Cathedral and the Tower of London. It traveled down the rivers of Normandy to the building sites of the Isle of France. It was among the most valued building materials in the northern medieval world. Other quarries supplied other buildings. The builders of Chartres drew stone from deposits in the surrounding region of the Beauce. The great cathedrals of the Rhineland were built of a reddish sandstone quarried from the hills to the east. In England, the oolitic limestone of the Cotswolds, that warm honey-colored stone that still gives the villages of Gloucestershire their particular beauty, provided material for churches and abbeys across a wide arc of the Midland counties. Each major building tradition was shaped in part by the character of the stone available to it, for stone is not a neutral material. Its color and its texture and its workability all influence the finished building. The tight-grained limestone of the Isle de France allowed the French masons to carve with extraordinary delicacy, to cut the thin, intricate tracery of the Gothic window, the elaborate foliage of the carved capital, the undercutting of figures in relief that gives them the appearance of being detached from their background and about to step forward into the air. The coarser sandstones of the Rhineland resisted such delicacy, but held their broad forms magnificently, giving the German Gothic a massive grandeur that the French style, for all its elegance, sometimes lacked. The quarrymen descended at dawn and did not return to the surface until dusk. They worked by the light of tallow candles, fixed in iron holders against the rock face, or by the glow of burning bundles of straw that gave a brief and smoky brilliance before guttering out. The smoke of these lights accumulated in the underground chambers and passages, and the lungs of quarrymen, who spent years below ground, bore the evidence of it. The grey, gritty deposits of a working life spent breathing stone, dust, and smoke in roughly equal measure. Silicosis was not a word that existed in the medieval vocabulary, but the condition was familiar enough. The slow suffocation of men whose lungs had been filling since their youth with the fine dust raised by every blow of pick on stone. The primary tool of the quarryman was the iron pick, a heavy double-headed implement with a long wooden handle, swung in a rhythm that the experienced man could sustain for hours without apparently tiring. Though his hands and shoulders and lower back told a different story at the end of the day. The pick was used to cut channels in the rock, vertical channels that defined the sides of the block to be removed. horizontal channels above and below. Once the channels were cut deep enough, wooden wedges were driven into the rock along the intended line of cleavage. The wedges were sometimes wetted, so that the wood would swell and exert a slow, irresistible pressure against the stone. Sometimes iron wedges were used and driven by hammers in a sequence, tap, 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 moving along the line of wedges and striking each in turn, so that the pressure built gradually and evenly along the entire length of the cut. And then, with a crack that could be heard through the whole underground chamber, the block would shear free along the line of its natural bedding, and the quarrymen would move quickly with crowbars to lever it clear of the face. The blocks removed in this initial stage were rough and irregular. They were moved on wooden sledges or in wheelbarrows to areas of the quarry where the primary dressing took place, the roughing out of the block into something approximating its final shape. This initial shaping was done underground, where possible, because every pound of waste stone removed at the quarry was a pound that did not have to be transported to the building site. Stone was heavy beyond the comprehension of those who have never worked with it in bulk. A single cubic foot of good limestone weighed somewhere between 100 and 150 pounds. The blocks used in a major cathedral might weigh several tons each. Transporting them was among the most expensive and logistically complex aspects of the whole building operation, and any reduction in the weight to be moved represented a significant saving. Each block that left the quarry bore a mark, a small carved symbol, usually geometric in form, cut into an inconspicuous face of the stone. This was the mason's mark of the man who had dressed it, and it served a double purpose. It was a mark of accountability, allowing the clerk of works to track which mason had produced which piece, and thereby to calculate and verify the pay owed to each man. And it was a mark of pride, the craftsman's signature on his work, invisible in the finished building but present within it, a record that this particular stone had passed through these particular hands. Some masons' marks have been catalogued and studied by modern scholars, who have traced the same mark appearing in different buildings across wide geographical areas, following a craftsman as he moved from site to site in search of work. Others appear only once, at a single site, suggesting a man who spent his working life in one place, or whose stone was so well incorporated into the finished structure that only a small number of his marked blocks remain accessible to inspection. Together, these marks constitute a kind of hidden history of the cathedrals, the signatures of the anonymous many, written in stone where almost no other record of them survives. The transport of stone from quarry to building site was organized with logistical care that rivaled anything else in the medieval economy. Where rivers allowed, stone was moved by water, loaded onto flat-bottomed barges, and floated downstream, which was infinitely more efficient than land transport. The Loire, the Seine, the Rhine, the Ouse, these rivers were highways of stone, perpetually busy with the slow traffic of building materials, moving from the places where they were cut to the places where they were needed. Where land transport was unavoidable, it was done with oxen drawing heavy wagons, on roads that were often inadequate for the loads they were asked to carry, and that had to be reinforced or rebuilt at the expense of the building project. The cost of moving stone from quarry to site could, in some cases, equal or exceed the cost of cutting it, which is why the master builder's choice of stone was always a balance between quality and proximity, and why local stone, even of inferior quality, was so often used for the bulk of the structure, while imported stone was reserved for the carved details that would be most visible. Stay of void. With spofdidi with both doved. Deeble be you up. With Bilby full with Vipple with the Bible of goal with the what with for with At the building site, the stone was received in a yard managed by the clerk of works, a literate administrator, often a cleric, responsible for the accounts and the logistics of the project. The yard was arranged with the efficiency of long practice. Stone of different types and sizes, sorted into separate stacks, clearly identified, accessible to the masons, who needed specific pieces. Beside the yard stood the lodge, the workshop of the masons, a long timber building open on one side to give light, equipped with the benches and templates and tools of the trade. Here, the stone received its final shaping before being lifted into position on the growing walls. The quarryman had done his part. He had reached into the earth and torn from it the substance of the cathedral. Now the mason would take that substance and, with patience and with skill and with the geometry that was his secret art, transform it into something that would stand for centuries as evidence that men had once believed so deeply in something invisible that they had been willing to devote their lives, and the lives of their children, and their children's children, to building it a home in stone. 4. The master builder's compass. The master builder carried no drawings as we understand them today. This is perhaps the first thing we must set aside. The modern assumption that any significant construction must begin with a complete set of documents, blueprints showing every dimension and detail, produced in advance and followed precisely by those who built. The medieval master builder worked in a world before such documents existed in any reliable or comprehensive form. Paper, in the early centuries of Gothic building, was scarce, and expensive vellum, made from calfskin, was the more common writing surface, and it was expensive enough that it was reserved for texts of permanence and importance. A working drawing was not considered a text of permanence. It was a tool, to be used and discarded, or rather to be superseded by the building itself, which was the only drawing that ultimately mattered.
What the master builder carried instead was geometry. Not geometry in the sense of a set of theorems to be proved, the geometry of Euclid as studied in the cathedral schools and universities, though some master builders certainly had acquaintance with that tradition. Rather, it was the geometry of the practitioner, a set of procedures, carried in the memory and expressed in the movements of trained hands, by which any required form could be generated from a small number of initial measurements. The master builder's primary tools were the compass, a device of two hinged legs that could be set to any radius and used to draw circles and arcs, and the rod, or measuring staff, which was his standard unit of measure, agreed upon at the outset of a project, and used by every craftsman on the site as the common reference against which all other dimensions were checked. From the compass and the rod, everything else followed. The rod was not a universal standard. It varied from region to region, from project to project. The foot, the inch, the yard, the ell. These were measures that existed in the medieval world in many local variants, and the lack of standardization that so frustrates modern historians was not necessarily a problem for the builders themselves, provided that everyone on a given site was working from the same agreed measure. What mattered was internal consistency, the preservation of the proportional relationships that governed the form of the building. A Gothic cathedral did not need to be exactly the same size as any other cathedral. It needed to be internally coherent, its dimensions related to each other by the ratios that the master builder had determined would produce the forms he intended. And those ratios could be expressed entirely in terms of the relationship between a given measure and its geometric derivatives, its square root, its diagonal, the side of an equilateral triangle constructed upon it. These were the operations the compass performed, and the master builder could carry them in his hands and his eyes, with a precision that is astonishing when we consider the results. The tracing house was the space where this geometry was worked out and made available to others. It was usually a room, sometimes a dedicated building, sometimes a loft above the lodge, with a floor of plaster or gypsum, smooth and white, large enough to draw full-size templates of the building's curved elements. On this floor, the master builder scratched his working drawings with a metal point, laying out arches and molding profiles and window tracery at full scale, so that the masons could take templates directly from the drawing without any scaling. A template was a thin piece of wood or stiff parchment cut to the exact profile of an arch soffit, or a column capital or a molding, the shape that a particular stone needed to be cut to in order to fit its position in the building. Templates could be duplicated, passed from one mason to another, used to check a piece of work in progress against the required form. They were the link between the master builder's geometry and the working mason's chisel, the means by which a single mind's conception was translated into the coordinated labor of hundreds of hands. The geometry that governed the design of a Gothic cathedral was not arbitrary. It was derived from a small number of fundamental figures: the square, the equilateral triangle, the regular pentagon, and from the ratios generated by the construction of these figures using compass and strategy. The diagonal of a square is related to its side by the ratio we now call the square root of 2, approximately 1.414, an irrational number that cannot be expressed as a simple fraction, but that can be constructed geometrically with perfect accuracy using a compass. The height of an equilateral triangle relates to its base by the square root of 3, approximately 1.732, another irrational that geometric construction handles effortlessly. The master builder, who understood how to generate these figures and extract these ratios, had, in effect, an infinite supply of proportions that related harmoniously to each other, because they all derived from the same geometric root. The application of this geometry to the cathedral's plan and section was systematic and cumulative. The width of the nave determined the height of the nave arcade. The height of the nave arcade determined the height of the triforium above it. The triforium determined the height of the clerestory above it, and the clerestory determined the height of the vault. These relationships were governed by geometric ratios, by the progressive application of root 2 or root 3 proportions to a single initial dimension, so that the entire vertical composition of the building could be generated from the width of the nave alone, using nothing more than a compass and the knowledge of which geometric operations to perform. Different masters chose different systems, and the variation in proportion between, say, the tall, slender nave of Amiens and the broader lower nave of Canterbury reflects genuine differences in the geometric systems their builders employed. But all of them were working within this tradition of geometric derivation, producing buildings whose proportions felt inevitable and harmonious, not because those proportions had been calculated in the modern sense, but because they had been grown, organically, from a single geometric seed. The master builder guarded his geometric knowledge with the ferocity of a man protecting something genuinely valuable. The procedures by which the forms of the building were generated were the core of his professional identity and the foundation of his economic power. A master who could be replaced by anyone who had read the same books had very little leverage over his patrons. A master whose knowledge lived in his hands and could not be transferred except by long apprenticeship under his direct supervision was irreplaceable, and he knew it. The lodges, the organizations of working masons that managed the transmission of craft knowledge, maintained a degree of secrecy about their methods that was not merely customary but strategic, and the later traditions of Freemasonry, with their elaborate ritual of secrecy and initiation, are a distant echo of this professional guardedness. The secrets of geometry were not arcane in the sense of being magical or esoteric. They were secrets in the simpler and more powerful sense of being knowledge that only some men possessed, and that those men had worked hard to acquire and had every reason to control. Yet the knowledge was not static. Each master builder brought his own experience and his own experiments to bear upon the tradition he had inherited. The history of Gothic architecture is, in one sense, a history of geometric experimentation, of masters pushing their systems further, finding new proportions, discovering new structural possibilities that their geometry opened up. The progressive increase in the height of Gothic naves over the 12th and 13th centuries was not simply a matter of ambition. It was the product of geometric exploration of builders who discovered that certain proportional systems, when pushed to their logical extreme, produced structures of extraordinary height and delicacy that still stood and still held their form. And when a nave collapsed, as they sometimes did, when the exploration went too far, the failure was absorbed into the tradition as a lesson. The next master builder who attempted something similar would take account of what had failed, would reinforce the elements that had buckled, would approach the limit more cautiously. The knowledge was collective in this way, distributed across the profession through the movement of craftsmen between sites and the stories that traveled with them. The master builder's compass, then, was not a simple measuring tool. It was the instrument through which an entire system of thinking about form and space and proportion was expressed and transmitted. It was the link between the vision, the theological and aesthetic program that Suger had articulated and that the cathedral was intended to embody, and the physical reality of stone cut and laid by many hands. When the master builder set his compass to the plaster floor of the tracing house and drew the arc that defined the curve of a great arch, he was performing an act that was simultaneously mathematical and spiritual, technical and artistic, individual and collective. He was translating an idea about the nature of God and the aspiration of the human soul into a shape that could be held in a craftsman's hand, transferred to a piece of stone, and, stone by stone and arch by arch, raised into the sky. The raising of the walls. The earliest work was invisible, and this invisibility was one of the most important facts about the building of a cathedral, a fact that those who funded the work, who watched for progress and measured their investment against visible results, found perpetually difficult to accept. Before a single wall rose above a man's head, before any stone could be seen from the street or pointed to by a hopeful bishop as evidence of achievement, the laborers had been digging for months, and sometimes for years. The foundations of a great cathedral were an immense undertaking, a project within the project, consuming enormous quantities of labor and material and leaving nothing visible to show for it, nothing but a series of wide, deep trenches running across the building site, filled and refilled with rubble and lime mortar, tamped and tested, and gradually becoming, under the careful management of the master builder, the invisible platform upon which everything else would rest. The trenches were dug to widths and depths that varied according to the master builder's assessment of the subsoil, and according to the loads that the wall above each section of foundation would carry. The piers, the great clustered columns from which the arches of the nave sprang, would impose the highest loads, concentrated at their bases, and so the foundation beneath each pier was a massive pad of rubble and mortar, sometimes as wide as the pier was tall, spreading the load over the largest possible area of the subsoil. Between the piers, the wall carried less weight, and its foundation could be somewhat shallower and narrower. This differentiation of foundation depth was itself a form of structural understanding. The master builder was, in his own terms, recognizing the principle that the intensity of pressure upon the soil depended on the ratio of load to area, and that the way to reduce excessive pressure was to increase the area over which the load was spread. The materials of the foundations were not the same as the materials of the walls above. Dressed stone, the carefully cut and shaped blocks that would form the visible faces of the walls, was expensive, time-consuming to produce, and unnecessary underground, where no one would ever see it. The foundations were built of rubble, broken stone of whatever type was locally available, lumps of flint, pieces of earlier structures demolished to make way for the new building, packed tightly together and bound with lime mortar. The quality of the mortar was critical. It was made by burning limestone in a kiln, a process that drove off the carbon dioxide bound in the rock and produced quicklime, an extraordinarily reactive substance that would burn the skin and produce tremendous heat when water was added to it. The quicklime was slaked, combined with water in a process that generated visible steam and required careful management to produce a white paste that, when mixed with sand in the right proportions, would harden over days and weeks into a material nearly as strong as the stone it bound together. The skill of the mortar mixer, the limner or lime worker, was more significant than is often recognized. Poor mortar, too thin with water, or mixed in wrong proportions, or made from poorly burned lime, would not harden properly and would fail gradually under load, causing the wall above to crack and settle. Good mortar, made by a skilled hand from well-burned lime and clean sharp sand, mixed to the right consistency and applied in beds of the right thickness, would harden to a degree of strength that the centuries would not diminish. The mortar in the walls of the great cathedrals that still stand has, in many cases, been tested by modern engineers and found to be harder than the stone it joins, a tribute to the craft of men whose names were never recorded and whose work was never intended to be seen. Once the foundations had been brought to the level of the surrounding ground, and in some cases somewhat above it, to protect the base of the walls from standing water, the masons could begin the visible work, the raising of the walls themselves. The fundamental technique was ancient, two facing skins of dressed stone, laid in level courses with their joints staggered to distribute the load, with the hollow space between them filled with the same rubble and mortar construction used in the foundations. This composite construction, ashlar facing with a rubble core, was not an economy measure, though it was certainly more economical than building the walls solid with dressed stone throughout. It was also structurally sound, provided that the two facing skins were properly bonded to the core and to each other by long stones, called through-stones or bond-stones, laid transversely so that they ran from one face to the other and tied the whole thickness of the wall together. Without this bonding, the two faces could separate from the core and from each other. The core would compress under load, while the faces were left unsupported, leading to a progressive failure that began with cracking and ended with collapse. The masons who laid these walls were specialists of a high order. The working mason, the man who cut and laid the stone, was distinguished from the rough mason who broke stone to approximate size, and from the freestone mason, the most skilled of all, who worked the fine limestone that could be freely cut in any direction and who was responsible for the carved details, the molded arches, the tracery of the windows, the capitals of the columns. But even the ordinary working mason who laid the wall courses had to possess a thorough understanding of his material and his craft. He knew how to set a course of stone level using a plumb line and a straight edge, checking continuously that the surface of the wall remained flat and vertical, correcting small errors of level before they accumulated into large errors of alignment. He knew how to bed each stone in mortar of the right consistency, not so wet that it would be squeezed out from under the stone's weight, not so stiff that it would not spread evenly under the stone's surface. He knew, with the hand that handled each block, whether the stone was right side up, whether its natural bedding planes were oriented correctly, the way the stone lay in the earth, so that the compressive load of the wall above would press upon the stone in the direction it was best able to resist. This last point, the orientation of the stone's bedding planes, was one of the most important pieces of knowledge the mason possessed, and one of the hardest to transmit to the uninitiated. Sedimentary stone, like limestone, is laid down in layers, and along those layers, the bedding planes, the stone can be split relatively easily. Across the layers, it is far stronger. A stone laid with its bedding planes running horizontally, as it lay in the earth, would bear a vertical load well. The compressive force of the wall above, pressing along the grain of the stone, between its layers. But a stone laid with its bedding planes, running vertically on edge, was vulnerable to splitting under vertical load, and to the action of frost, which would work its way into the tiny horizontal fissures between the layers, and expanding as it froze, work the layers apart. The mason who turned a stone the wrong way was doing damage that might not be visible for decades, but that would eventually express itself in a spalling, disintegrating surface and a weakened wall. This knowledge lived not in books but in hands, in the fingertips that could feel the grain of the stone, in the eye that could read the faint stratification lines visible on a freshly cut face. The pace of construction was slow by any modern standard, and it was governed not by the ambitions of the builders but by the properties of the mortar. Fresh mortar required time to cure, to undergo the chemical reactions that converted it from a plastic paste to a hard, crystalline solid. During this curing, it was vulnerable to being disturbed or overloaded, and so the masons could not simply pile stone upon stone without limit. They had to raise the wall to a certain height and then stop, allowing the mortar to harden before adding more weight above it. In practice, the length of each building season was also constrained by the weather. In cold weather, the water in fresh mortar could freeze before the lime had reacted, and frost-damaged mortar was weak and crumbly, incapable of performing its binding function. The building season in northern France and England ran roughly from March to October, 6 or 7 months of work, followed by a winter in which the walls were left to stand and the mortar was left to cure, the tops of the unfinished walls covered with straw or timber to protect the fresh bedding mortar from frost. Year by year, the walls climbed, and the accumulation of many seasons' work raised the cathedral toward the height the master builder had envisioned. The scaffolding that supported this work was a structure of timber almost as complex as the stone building it served. The masons who laid the high courses of the walls, and the setters who placed the keystones of the arches, worked at heights that required platforms of timber poles lashed together with rope or bound with iron, carrying platforms of boards wide enough for a man to stand and work and for the mortar and stone to be delivered beside him. The timber for this scaffolding was a significant material cost in the building accounts, and the carpenters who erected and struck the scaffolding were as essential to the construction as the masons who worked from it. The poles were inserted into the wall in holes left for the purpose, putlog holes, that can still be seen in the walls of many medieval buildings, sometimes filled later with mortar, sometimes left open, a permanent record of the timber structure that was removed when the masonry it supported had hardened and could stand alone. And in this slow way, course by course, season by season, year by year, decade by decade, the walls of the cathedral rose toward the height that the master builder had promised the bishop they would reach, and that the bishop had promised God they would honor. The rising of those walls was not merely construction, it was an act of collective faith, sustained across generations, embodied in the daily labor of men who got up before dawn and climbed the scaffolding in the cold and laid their stones and checked their levels and went home at dusk to eat and sleep and rise again the next morning. The cathedral was built in days, each one like the last, each one a small increment of the immense whole, and the immense whole was not an abstract idea but a felt obligation, a promise that the community of builders and patrons and worshippers had made to heaven, and that the slow rising of the walls, course by 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 course of course was course course war core or report wisser or wisit war of dog well of swekak Six. The art of the pointed arch. The great secret of the Gothic builders, the single innovation from which nearly everything else followed, the hinge upon which an entire architectural revolution turned, was not, in itself, a complicated thing. It was a small adjustment, almost modest in description, to the geometry of the arch. The older tradition, which we call Romanesque, and which the medieval builders themselves thought of simply as the received way of doing things, had used the semicircular arch. This is the arch whose curve describes exactly half a circle. Its two legs rise from their abutments, at a point level with its own center, and the curve describes a perfect half circumference before meeting its opposite leg at the crown. The semicircular arch is a form of great beauty and considerable strength. The Romans had used it to build aqueducts and amphitheaters and the mighty barrel vaults of their baths and basilicas. It had survived the fall of the Western Empire as the natural form of the arch, reproduced by the builders of early Christian churches and by the Carolingian builders of the 9th century and by the Romanesque builders of the 11th, who used it everywhere, in doorways and windows and nave arcades and the great tunnel-like barrel vaults that covered their church interiors with an unbroken curve of stone. But the semicircular arch imposed a constraint that became, as ambitions grew, an increasingly severe limitation. The constraint was this: the rise of a semicircular arch is always exactly equal to half its span. If the arch spans 20 feet, if its two abutments are 20 feet apart, then it will rise exactly 10 feet above the level of its springing points. This is not a matter of choice or of skill. It is a geometric inevitability. And this inevitability created a problem for the builders of great church interiors, where the nave and the aisles were of different widths and where the desire was to bring them to a common ceiling height. If the nave was 40 feet wide and the aisles were 20 feet wide, and both were to be covered with semicircular arches, then the nave vault would rise 20 feet above its springing point, and the aisle vault would rise only 10. Either the floor levels had to be adjusted, a complex and often aesthetically unsatisfactory solution, or the aisle vault had to be distorted somehow to bring it up to the height of the nave vault, which required the use of stilted arches or other awkward expedients. The semicircular arch was, in the full sense of the word, inflexible. The pointed arch dissolved this constraint as elegantly and completely as a theorem destroys a false assumption. The pointed arch is formed not from a single circle but from two circular arcs that meet at a point at the crown. The centers from which these arcs are drawn can be placed anywhere along the base of the arch, and by varying the position of the centers, the builder can vary the steepness of the point, how sharply or how gently the two curves meet at the top. This seemingly small degree of freedom has enormous consequences. By adjusting the angle of the point, a builder can make arches of any width rise to any height. A narrow arch can be made to rise as high as a wide one. A wide arch can be kept low where the structure demands it. The height of the arch is no longer a function of its width. It is a variable, independently controllable, subject to the builder's intention rather than to geometric necessity. This freedom transformed the plan of the cathedral from a problem to a possibility. With pointed arches, the nave and aisles could be covered at the same height, regardless of their different widths. The transept, crossing the nave at right angles, and likely of yet another width, could be brought to the same ceiling height as both. The choir, the ambulatory, the radiating chapels, all could be vaulted at whatever height the master builder determined was right for the whole composition, without being constrained by the width of each individual bay. The interior of the building could be a unified vertical space, the eye drawn upward from every point to the same height. The whole interior reading as a single room of immense height, rather than a series of compartments, each struggling to accommodate the geometry of the arch above it. But the pointed arch did something else as well, something that operated on the senses rather than on the intellect. The semicircular arch leads the eye in a curve that falls away on either side of the crown, a curve that is at its steepest at the springing points and horizontal at the top, so that the eye, following the curve upward, is decelerated as it approaches the crown and arrives there with a sense of rest, of completion, of having reached a point of balance. The pointed arch does the opposite. Its two curves converge toward the crown, growing steeper as they rise, so that the eye, following the curve upward, is accelerated toward the point, driven upward with an urgency that the semicircular arch does not possess, arriving at the crown, not in rest, but in a kind of arrested momentum, as if the stone was still trying to rise, and only the convergence of the two curves had stopped it. The pointed arch aspires. This is not a metaphor imposed after the fact. The builders and the patrons and the worshippers who used these buildings felt it as a physical sensation. The interior of a Gothic cathedral, with its forest of pointed arches rising on every side, exercises an upward pull on the attention that is unlike anything produced by a Romanesque interior, and this pull is inseparable from the geometry of the pointed arch. The ribbed vault, the other great structural innovation of the early Gothic period, was made possible by, and was, in a sense, the fulfillment of the possibilities opened by the pointed arch. The vault is the ceiling of the medieval church, and it was, for the builders of this period, an object of consuming technical and aesthetic attention. The earlier tradition had used the barrel vault, an unbroken tunnel of stone, a half-cylinder stretched along the length of the nave, or the groin vault, formed by the intersection of two barrel vaults at right angles. Both of these forms presented difficulties. The barrel vault exerted a continuous outward thrust along its entire length, requiring the walls below it to be very thick and admitting very little window openings. The groin vault was structurally more complex, concentrating its thrust at the four corners where the two half-cylinders intersected, but the construction of the intersection, the groin, required very precise geometry and was difficult to execute accurately without a complete timber framework, called centering, supporting every part of the vault until the mortar had hardened. The ribbed vault solved both problems at once. It was constructed by first building the ribs, narrow arched bands of stone, 1 or 2 courses deep, that ran from the springing points of the vault to its crown in a pattern of diagonal and transverse arcs. These ribs were relatively easy to build, requiring only a light timber centering for each rib individually, rather than the massive continuous centering needed for a barrel or groin vault. Once the ribs were built and their mortar had hardened, they stood independently, forming a skeleton of stone that could carry weight. The spaces between the ribs, called the webs or sévres, were then filled with thin stone panels, curved to the shape defined by the ribs, but thinner and lighter than any of the earlier vault forms. The load of these panels was carried by the ribs to the points where the ribs converged at the top of the piers, the springing points, and from there it passed down through the piers to the foundations. The elegance of this system was that it separated the structural function of the vault from its enclosing function. The ribs were structural, they carried the loads. The webs were enclosing, they kept out the weather and defined the interior space. Because the structural function was concentrated in the ribs, the webs could be thin as 8 or 9 inches in some cases, and their thinness reduced the weight of the vault dramatically compared with earlier forms. A lighter vault meant lower thrusts to be resisted by the walls and buttresses below, which meant that the walls could be thinner, and thinner walls meant more room for windows. The logic was circular and mutually reinforcing. The ribbed vault enabled thinner walls enabled larger windows let in more light, and more light fulfilled the theological program. Suger's vision of a building flooded with heavenly luminosity that had set the whole enterprise in motion. The pointed arch made it possible for the ribs of the vault to rise to the same height from any direction, regardless of the different spans they had to bridge. The diagonal ribs of a rectangular bay, arching from corner to corner, and therefore longer than the transverse ribs, which ran across the shorter dimension, could be given a steeper point to compensate for their greater length, so that all the ribs in a bay arrived at the same height at the crown. Without the pointed arch, this adjustment would have been impossible, and the construction of a ribbed vault over anything other than a square bay would have required complex and unsatisfactory distortions of the vault geometry. With it, the vault could cover rectangular bays with mathematical neatness and visual grace. The mastery of these relationships, between the pointed arch and the ribbed vault, between the vault and the wall, between the wall and the buttress, between the buttress and the ground, was the central intellectual achievement of the Gothic builders. It was not achieved at a single moment or by a single mind. It was the product of decades of experiment and observation, of buildings constructed and modified, and in some cases partially collapsed and rebuilt, of the gradual accumulation of practical knowledge about what worked and what did not, knowledge that was transmitted through the movement of craftsmen, through the observation of finished buildings, through the slow sedimentation of experience in the traditions of the lodge. The pointed arch was the key that unlocked the system, but it took generations of builders to understand fully what it unlocked, and to push through that unlocked its spaily what it unlocked, and to push through that unlocked door, and to construordinary with the extraordinary spaces could score it, could see, could skid, could skip, could specifics, could miss six stick, could mark, zog, and it gag, can, better, with here, who could suffer, bucked with good to agwiak, without quick with the step, act, but with up, quick, but ask, plug off, plug school, capet, school, was though, get it most, cusp, stove, was fulfilling at last the promise that Suger had made in a small church north of Paris in the year of our Lord 1144, when he stood in his new choir and felt, or imagined he felt, that the ordinary earth had for a moment been left behind. 7. The skeleton of stone. The truly revolutionary idea of the Gothic builders, the idea that, more than any other single conception, separates the Gothic tradition from everything that came before it in the long history of European architecture, was the idea of the skeleton. It was an idea so counterintuitive, so contrary to the deep instinct that associates mass with safety and thickness with strength, that it is worth pausing to understand what the builders were overcoming in themselves when they first began to pursue it. Every human being who has ever sheltered under a roof understands in the body, not merely in the mind, that a roof must be supported, and that the supports must be solid, and that solidity means thickness and weight. The cave is the primal model of shelter, and the cave works by mass. The mountain above you is what keeps you safe, and the mountain is safe because it is enormous, because there is so much of it that no force imaginable can displace it. The earliest stone buildings translated this instinct into construction. Thick walls, small openings, low ceilings, the whole mass of the structure pressing downward and inward with a gravity that felt like permanence. To depart from this model required not merely technical ingenuity, but a kind of intellectual courage, the willingness to trust a system that looked, to ordinary eyes, terrifyingly fragile. The earlier tradition of Romanesque building had not entirely escaped the cave. The great Romanesque churches of the 11th and early 12th centuries, the Abbey of Cluny, the Cathedral of Durham, the pilgrimage churches of the road to Santiago, were buildings of immense power and dignity. But they were buildings in which the wall was still the fundamental structural element. The wall bore the weight of the vault above it. The vault exerted a thrust, not merely a downward force but an outward one, a tendency of the arched stone ceiling to spread its legs and push the walls apart, and the wall had to resist this thrust with its own mass. This meant that the walls had to be thick enough, heavy enough, inert enough, to simply absorb the lateral force without moving. The builders achieved this through sheer material bulk, making the walls of their great churches 3, 4, sometimes 5 feet thick, occasionally more. These walls were not merely structural, they were the building. They contained the space, defined it, embodied the idea of enclosure. And because they were so thick and so massive, the openings cut through them. The windows had to be small. Every opening was a weakening. Every window was a hole in the structural fabric. The light that came through those windows was precious precisely because it was so limited, falling in narrow shafts through deep embrasures, pooling on the stone floor below in patterns of gold and grey that were beautiful, partly because of their rarity. The Gothic builders discovered, not all at once, not in a single moment of revelation, but through the cumulative process of experiment and observation that has already been described, that they could abandon this model entirely. They could build a building in which the wall, in the structural sense, had almost ceased to exist. The key insight was that the forces acting on a vault did not need to be resisted everywhere they acted. They could be gathered, directed, channeled. The thrust of the vault was not a diffuse pressure spread uniformly across the entire wall surface. It was a force that, in a ribbed vault, was concentrated at specific points, the points where the ribs converged and descended to their springing points at the tops of the piers. If the thrust was concentrated at a point, then the resistance to that thrust needed to be provided only at that point, not along the whole length of the wall. The wall between the piers, the section of wall that in a Romanesque building was doing nothing except carrying the vault thrust and providing the enclosure of the space, could be freed from its structural obligation. It needed to carry nothing, and if it needed to carry nothing, it could be made as thin as a single stone, or it could be opened entirely and replaced with glass. This liberation of the wall from its structural role required a new system for collecting and conducting the forces that the wall had previously resisted. The Gothic builders developed this system with extraordinary ingenuity, working out its implications over several generations, pushing it further with each cathedral until it reached a degree of refinement that still astonishes the structural engineers who study it today. The system had two main components: the internal skeleton, consisting of the piers and ribs that gathered the vault's forces and conducted them downward to the foundations, and the external skeleton, consisting of the flying buttresses and outer piers that intercepted the lateral thrust before it could displace the wall and conducted it safely to the ground. The internal skeleton began with the piers, the massive cylindrical or square columns of the Romanesque tradition, columns whose bulk was in part a structural necessity and in part an expression of the aesthetic of mass that governed the whole building, were replaced in the Gothic system with clusters of thinner, lighter shafts, bundled together and rising uninterruptedly from the floor to the point where they spread into the ribs of the vault above. This uninterrupted rise was itself a visual expression of the structural logic. The eye followed the shafts upward, understood intuitively that they were doing something, carrying something, and was led naturally to see the connection between the slim column below and the spreading rib above. The cluster of shafts was arranged so that each shaft corresponded to a specific rib. The central shaft of the cluster carried the main transverse rib, the flanking shafts carried the diagonal ribs, the smaller shafts between them carried the subsidiary ribs of the more complex vault patterns that developed as the more complex vault patterns that developed as the Gothic Patrif plever with the satis of Clesicis of Trisefet bout at Peplek, and with kin out with that with and with cup to pepwes up will that up buck of das at up God pick up cat up to hapat with fat got up cast out all hack palka fuck it pagat fluftum to kakakas this fig visk up that's blue was cup labelous was the pier was, in effect, a diagram of the vault above it, a map of forces expressed in stone. Above the piers, the ribs of the vault did their gathering work, collecting the distributed weight of the thin stone web panels and concentrating it into lines of force that converged at the springing points and then descended, as a column of largely vertical force, through the piers to the foundations. The geometry of the ribbed vault was such that the ribs of adjacent bays created a continuous structural network across the whole ceiling of the building, each rib connected to its neighbors, the forces in each balanced and resolved against the forces in the others, the whole vault acting as an integrated structure rather than a series of independent units. The master builder who understood this network, who could trace the paths of force through it and identify the points where resolution was achieved and the points where it was not, was in possession of a structural understanding of extraordinary depth, even if he could not have expressed it in the mathematical language we would use today. But the gathering of vault forces into the piers solved only half the problem. The forces collected at the piers were not purely vertical. The arch, even the pointed arch, still exerted a horizontal component of thrust, a tendency to spread outward at its base, and this horizontal thrust, concentrated now at the tops of the piers, had to be resisted by something. In the earlier and simpler Gothic buildings of the mid-12th century, this resistance was still provided partly by the wall between the piers, thickened at the aisle level where the thrust was greatest, reinforced with shallow internal buttresses, and partly by the simple weight of the pier and its superstructure. But as the buildings grew taller, and as the desire for ever larger windows ate away at the wall between the piers, this arrangement became increasingly inadequate. The thrust at the top of a tall pier, far above the level of the aisle roof, could not be resisted by a wall that had been largely replaced with glass. Something had to be brought from outside, from the world beyond the enclosing wall, to push back against the outward thrust and hold the pier upright. This something was the flying buttress, and the story of how the Gothic builders arrived at it is itself a story of structural understanding developing in real time, expressed in stone rather than in mathematics. The earliest flying buttresses were not flying at all. They were concealed beneath the aisle roofs, hidden arched props of stone leaning against the upper walls of the nave at the level where the vault thrust was greatest. Some architectural historians believe that these concealed props were not originally designed as structural elements at all, but were added during or after construction when the builders observed that the nave walls were beginning to move outward under the vault's thrust and needed to be propped back. Whether this is entirely accurate or whether some of the early concealed buttresses were planned from the beginning, the effect was the same. The builders discovered that an arched prop of stone, leaning against the thrust of the vault and conducting the force down to an outer support, was an effective means of resistance. The step from a concealed prop to a visible flying buttress was both a structural development and an aesthetic declaration. By bringing the buttress out from under the aisle roof, making it span openly across the void between the clerestory wall and the outer pier, the builders were accepting and then embracing the visible expression of structural necessity. They were saying, in stone, that the forces acting on this building were real and required real resistance, and that the resistance could be made beautiful. The flying buttress was not disguised or apologized for. It was elaborated, given moldings and carvings and pinnacles, and made into one of the most distinctive and expressive elements of the Gothic exterior. Standing outside a great Gothic cathedral and looking at the forest of flying buttresses that prop it on both sides, you are seeing the forces of the vault made visible. The structural logic of the building displayed on its exterior as clearly as the bones of an anatomical drawing. The Gothic cathedral was the first building type in Western history to make a virtue of showing its structure rather than hiding it, the first to treat structural honesty as an aesthetic principle. The pinnacles that rose above the outer buttress piers were not, as they are sometimes described in popular accounts, purely decorative additions, architectural accessories chosen for their picturesque quality. They had a structural function. And understanding that function reveals the depth of the Gothic builders' grasp of the forces they were managing. The flying buttress conducted a force that was not purely horizontal, it was angled, sloping downward from the point where it met the nave wall to the point where it met the outer pier. This angled thrust had both a horizontal component, which resisted the outward push of the vault, and a vertical component, which pressed down on the top of the outer pier. The pier needed to be stable against both the downward force transmitted through the buttress and the horizontal force that the buttress was resisting. Adding weight to the top of the pier, in the form of a pinnacle of carved stone, sometimes several tons of it, increased the vertical force pressing down through the pier and into its foundation, which increased the friction resistance of the foundation against horizontal sliding. The pier was held more firmly in place by its own greater weight. The pinnacle was ballast, and it was beautiful because the craftsmen who carved it could not conceive of making something purely utilitarian. Beauty and engineering occupied the same continuous spectrum of intention as they always had in this tradition, and as they perhaps always must in any tradition that builds in the full sense of that word. What was created by the combination of ribbed vault, clustered pier, and flying buttress was something that had no precedent in the history of construction. A building whose structural system was a skeleton of stone, minimal and efficient, from which the enclosing surfaces, the walls, the windows, the thin web panels of the vault, were suspended or infilled without bearing any structural load. The load path was clear, elegant, and total. Weight flowed from the vault webs to the ribs, from the ribs to the piers, from the piers through the flying buttresses to the outer piers, and from all of these down through the foundations to the earth. Everything else, the glass, the carved decoration, the thin panels of stone between the window tracery, was structurally irrelevant. It was there to enclose space and to be beautiful, and it was free to be beautiful in ways that a load-bearing wall could never be, because it bore no load. This freedom was the gift of the skeleton, and it was a freedom that the builders used with an exuberance, a proliferation of invention and ornament and light, that makes the great Gothic cathedrals among the most joyful buildings that human beings have ever made. 8. The flying buttress. To those who watched the great cathedrals being built, the townspeople of Chartres or Amiens or Reims, who lived in the shadow of the growing structure for years and decades, who saw the scaffolding rise and the stone walls climb and the flying buttresses appear against the sky like the limbs of some vast, slow creature emerging from a chrysalis of timber staging. These great arched props of stone must have seemed, in equal measure, magical and mad. They were unlike anything else in the visual vocabulary of the built world. A wall was a wall. It stood vertically, it enclosed, it supported. A column was a column, it rose and it bore weight. An arch was an arch, it spanned an opening, and it held the masonry above it in compression. But what was a flying buttress? It was an arch that spanned nothing. It was a wall that stood at an angle. It was a prop that seemed to be holding up a building that, from the outside at least, looked as if it ought to be able to hold itself up perfectly well without it. And it leaped. That was the word the builders themselves eventually came to use, the word that passed into the French architectural vocabulary as arc-boutant, the butting arch. The arch that pushes it leaped across the open air between the high wall of the nave and the massive outer pier, defying in its crossing every intuition about how stone was supposed to behave. The men who first designed the flying buttress in its mature, developed form, who brought it out from under the aisle roofs where it had been lurking, concealed and provisional, and exposed it to the air as a deliberate and permanent structural element, did not know that they were inventing something epical. They were solving a problem. The problem was specific and pressing. The high nave walls of the new Gothic churches were being pushed outward by the thrust of the stone vaults above them, and the walls were too thin and too full of window openings to resist this push from their own resources. Something had to push back. The flying buttress pushed back, and in pushing back it not only solved the immediate structural problem, but opened up the possibility of building even taller, even thinner, even more window-filled than had hitherto been conceivable. The solution was more powerful than the problem it solved, and the builders, recognizing this, pushed it further with each generation. The geometry of the flying buttress was the subject of considerable practical thought and refinement over the course of the 12th and 13th centuries. The buttress had to be inclined at the right angle, steep enough to intercept the vault thrust effectively, which meant being directed roughly toward the point where the thrust originated in the vault, but not so steep that the force it conducted to the outer pier became predominantly vertical, and therefore ceased to provide horizontal resistance. The determination of this angle was a matter of practical geometry and practical experience, and the records of the period, the building accounts, and the occasional theoretical texts by master builders that have survived suggest that it was the subject of genuine debate and experiment. Different masters chose different angles, and different parts of the same building sometimes have buttresses set at different inclinations, reflecting the evolution of the master builder's thinking as construction progressed. The first flying buttresses were relatively simple in form. A single arched half, one half of a pointed arch, springing from the nave wall at the level of the vault, springing and descending to the outer pier. This form was structurally adequate for the buildings of the late 12th century. But as the cathedrals grew taller in the 13th century, as the nave of Notre-Dame de Paris was raised, and the great cathedrals of Chartres, Reims, Amiens, and Beauvais attempted ever greater heights, the single flying buttress proved insufficient. The forces were larger, the heights were greater, and the single arch was not able to conduct the thrust to the outer pier with enough precision and enough strength. The builder's response was to develop the double flying buttress, two arched half-arches stacked one above the other, each intercepting the thrust at a different level. The lower buttress resisted the thrust of the main nave vault. The upper buttress resisted the thrust of the high wind loads on the thin nave clerestory wall, a force that the builders understood, not in the theoretical terms of structural engineering, but in the empirical terms of buildings they had seen damaged or deformed by wind. The double flying buttress was not the product of calculation. It was the product of observation and of a structural intuition that, in its results, frequently matched what calculation would have produced. The outer piers to which the flying buttresses were anchored were themselves objects of considerable structural and aesthetic elaboration. They had to be massive enough, heavy enough, wide enough at the base, to resist the combination of forces acting upon them. The downward thrust, transmitted by the flying buttress, the horizontal thrust that the buttress was conducting from the nave wall, and the lateral forces of wind acting directly on the pier itself. In the early Gothic buildings, these piers were relatively simple in form, thick rectangular masses of masonry, but as the tradition developed, they became more complex. They were given projecting colonnades, molded bases and capitals, carved niches containing figures of saints. They were topped with the pinnacles already described, whose structural function as ballast was inseparable from their aesthetic function as markers and ornaments. The great outer piers of a mature Gothic cathedral like Amiens or Reims are extraordinary objects in themselves, independent pieces of architecture, each with its own internal complexity, its own articulation of surfaces and projections, its own contribution to the silhouette of the building as seen from outside. The silhouette. This is perhaps the most underappreciated aspect of the flying buttress and its effect on the Gothic cathedral as a building. From a distance, the exterior of a great Gothic cathedral is one of the most complex and dramatic architectural compositions in the history of building. The main body of the church, its nave and choir, its transepts, rises to a height that would have been extraordinary in any previous age. Above it, the pinnacles of the clerestory and the bases of the towers push higher still. But surrounding the main body, at mid-height, is the crown of flying buttresses, arching outward and downward from the high walls, landing on their outer piers, rising again in their pinnacles, repeating in a regular rhythm around the entire perimeter of the building. This crown of buttresses gives the cathedral a profile unlike any other building type, organic and almost creature-like, as if the building had grown outward at its middle to balance itself, as a tree grows its canopy outward to balance the weight of its branches. The comparison is not entirely fanciful. The flying buttress system does for the cathedral what the root system does for a tree. It extends the structural base outward beyond the visible trunk, providing a stability against lateral forces that the trunk alone could not achieve. The cathedral and the tree are both solving the same problem: how to stand upright and tall in the face of forces that would overturn them, and the solutions, though arrived at by entirely different processes, have a family resemblance that is not accidental. They are both expressions of a structural logic that is, in some sense, universal. The craftsmen who built the flying buttresses, the masons who cut and set the voussoirs of the arched half-ribs, who built the centering on which the arches were turned, and then struck it when the mortar had cured, who set the pinnacles and carved the decorative details of the outer piers, worked at heights that would have been considered extreme even in a later age of professional construction. The outer piers of the clerestory level, flying buttresses of a great cathedral, rise 50, 60, 70 feet above the ground. The flying buttress itself, arching from this height to the nave wall at an angle, was constructed on timber centering suspended in the air. A temporary wooden arch, built first, upon which the stone arch was assembled voussoir by voussoir before the mortar hardened and the centering could be removed. A fall from this height was fatal, and falls happened. The building accounts of some cathedrals record payments to the families of workers killed in construction accidents, brief, matter-of-fact entries in the columns of expenditure, the ledger making no distinction between the death of a Pantachus of Apactius of countries, the letter of Mantrus of Lanchus of Apatchus of Canchan of Cuphasis of Papicius of Betchus of Abeb the Beb, with the Scuxcus of Bexipwick with Whipan Rip Papter Bur Bupman Mark of it with Pair of Atahatap Whip Ipata Pata Pap Whip What Up Gaga Cas Atgabat Muftebat Getakas Gaskakas Test Swift Post was thou spoon with never The men who built the flying buttresses knew what they were risking. They climbed the scaffolding anyway, day after day, season after season, because it was their trade and their livelihood, and, one suspects, because there was something in the work itself, the complexity of it, the height of it, the sense of being part of something that grew visibly larger and more astonishing with each passing year, that made it worth the risk. The flying buttress was, ultimately, a solution of extraordinary economy and elegance. It solved a structural problem that, by the standards of its time, had no solution: the problem of making a stone building of great height whose walls were largely glass. And it solved it with a minimum of material, a maximum of structural efficiency, and a visual drama that transformed the exterior of the Gothic cathedral from a plain expanse of masonry into one of the most animated and exciting architectural compositions in history. It is difficult, standing outside the apse of Notre Dame de Paris on a clear morning, watching the double flying buttresses leap from pier to pier in their great arc, to see them merely as structural elements. They look alive. They look like something frozen in the act of motion, great stone creatures caught in mid-lep, perpetually about to land, perpetually poised between the building they support and the earth that anchors them. They look, in short, like exactly what they are: the expression in stone of a force that has been understood, shaped, directed, and made beautiful by men who understood that engineering and art were not two different things but one thing seen from two different directions. 9. The windows of heaven. Once the skeleton of stone was complete, Once the piers were up, and the ribs of the vault were in place, and the flying buttresses were set, and the thin stone webs of the ceiling had been laid between the ribs, and the centering had been struck, and the vault stood, tense and resolved. In its own internal equilibrium, the glazers came. They came to fill the gaps, and in filling the gaps, they transformed the building. What had been, even in its completed structural state, a building of considerable beauty, the play of light and shadow on the carved stone surfaces, the elegant geometry of the vault ribs overhead, the forest of clustered piers rising to their springing points, became something of an altogether different order. The windows of a Gothic cathedral are not simply openings filled with decorated glass. They are walls of light, surfaces that do not merely admit light, but transform it, color it, fracture it into 1,000 separate hues, and then recompose it in the interior as something richer and stranger and more alive than ordinary sunlight has any right to be. The craft of the medieval glazer was ancient. Colored glass had been made since Roman times, and the early medieval period produced windows of considerable beauty, though simpler in technique than what was to come. The essential material was pot metal glass colored in the furnace itself by the addition of metallic oxides to the molten batch. Copper oxide produced greens and, in higher concentrations, blues of extraordinary depth. Iron oxide gave yellows and browns. Manganese produced purples and violets. Cobalt, which was expensive and had to be imported from the mines of Central Europe, gave the intense, saturated blue that is the most distinctive color of the great Gothic windows, the blue of Chartres, which has never been precisely reproduced, and which still, after 8 centuries, stops visitors in their tracks in the nave of that cathedral. A blue so deep and so luminous that it seems less like light passing through glass than like light being generated by the glass itself. Gold ruby glass, among the most technically demanding of all, was made by reducing copper in the melt, a process that required careful control of the furnace atmosphere, and produced, when it succeeded, a red of such depth and warmth that it reads in the finished window as the color of a coal fire seen through translucent stone. The glass was made in sheets by one of 2 methods. The muff method involved blowing a large gather of molten glass into a cylinder, a long sausage of glass, which was then cut along its length and flattened in the annealing oven into a sheet. The crown method produced a disc of glass by spinning a gather of molten glass at the end of a blowing iron until centrifugal force spread it into a flat circle. Crown glass retained a characteristic rondelle, a thicker circle at its center where the iron had been attached, and the slight unevenness of its surface and thickness gave it an optical quality that is different from modern flat glass, refracting the light as it passed through in a way that made the color seem to pulse and shift as the angle of illumination changed. Both methods produced glass of relatively small maximum dimension, sheets perhaps 2 or 3 feet in their longest direction, which meant that the great window pieces of the glass be virtual, is meant that the great winty of pieces and bound together are with lead is, assembled besebid, assembled, assembled, simbended, segend, embedix, enisig, gex, kingin in with dom with cog, and rit down, for as well sisqua with the da, with a that, sacriflex, what to book back, what path, what would but ha 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 da ha gesek eso kaka cool dekas cut because but better has go of lots. That's what was the difficult of The cutting of the glass was done not with a diamond or a glass cutter in the modern sense, but with a hot iron rod called a grozing iron. The glazer would score the surface of the glass. With the hot iron, the heat causing a slight expansion that created a line of stress, and then tap the glass gently from below along the score line, causing it to crack cleanly. The resulting piece could be refined further by nibbling its edges with a grozing iron, a slightly different tool with a notched jaw that bit small chips from the edge of the glass, allowing the glazer to follow curved cutting lines with reasonable precision. With practice, a skilled glazer could cut remarkably complex shapes, the interlocking curves and points that the Gothic window compositions demanded, and could assemble them so tightly that the lines of lead between them followed the design with the precision of a drawn line. The lead, the cames, as the strips of lead used to join the pieces of glass were called, was H-shaped in cross-section, so that it could grip the edge of the glass on both sides of its central web. The pieces of glass were slid into the grooves of the cane, and the cane was soldered at its joints with a tin-lead alloy melted with a hot iron, fixing the whole assembly into a rigid panel. The pattern of lead lines in a finished Gothic window was not merely a structural necessity, a way of holding the glass together, but an integral part of the design. The glazier worked from a drawing, called a cartoon, which showed the full composition at full scale, with the lead lines drawn in, as part of the design from the outset. The outline of each individual piece of glass determined not merely by the image it contributed to, but by the practical requirement that no piece be so large that it could not be held securely by the lead around it, and no piece so small that it could not be cut with reasonable precision. The cartoons were drawn on a whitened wooden table or on a flat surface of lime plaster, prepared fresh for each window, at full scale. The master glazier would draw the overall composition in chalk or charcoal, refining it by eye until the proportions were right and the figures read clearly at the distance from which they would be seen. Medieval window designs were not intended to reward close inspection in the way that a panel painting might. They were intended to be read from a distance, from the nave floor looking up at the clear story, and this requirement shaped every decision the glazier made about the scale of the figures, the boldness of the outlines, the intensity of the color. A figure painted in grisaille on glass in the grey paint made from iron or copper oxide that was fired onto the glass surface to add detail to the colored pieces had to have its features enlarged and its modeling simplified, because at 60 feet of distance the fine gradations of a realistic painting would dissolve into an undifferentiated smear. The great glaziers of the 13th century understood this with complete mastery, and the figures in the great windows of Chartres or the Sainte-Chapelle have an expressiveness and a communicative force that depends entirely on their calculated departure from naturalism, on the bold eloquence of cortualism, on the bold elasticis of Catchley, on the Belfort by Sephant on comment pessisin, on sox sepul in it, sox cat wick, plet without, we happen with it, clop with ink. With slick, with sadness, kick without attacks, with up minsk, with up make move with the half clap with up work up white, go off order, their fast cacapac of a house, Mikagas, close part of that packets, bubble, but first it can space the flat color fields, the schematic faces that read across the full width of the building with an authority that a more realistic treatment could never achieve. The windows were assembled in panels, sections of perhaps 2 feet by 3, each a self-contained structural unit, and these panels were set into the stone frames of the window openings, the tracery, and held in place by iron armatures set into the stone, and by saddle bars, horizontal iron rods to which the lead matrix of the window was soldered at intervals to prevent it from bulging outward under wind pressure. The iron was the window's structural support. The lead alone was not rigid enough to resist the forces of wind on a large window surface, and without the iron armatures the window would deform and eventually break. The ironwork was thus as important as the lead and the glass, and the blacksmiths who made it were as essential to the glazing program as the glazers themselves, yet another trade among the many that the cathedral required, and that, in requiring, sustained across the generations. The subjects depicted in the windows were determined by the cathedral chapter, the clergy who governed the cathedral, in consultation with the donors who funded them. Each window was typically paid for by a specific donor, a guild of merchants, a noble family, a bishop or archbishop, sometimes the king himself. The donor's identity was recorded in the window itself, usually in a panel at the base of the composition, showing the donors at work, or at prayer, or presenting their gift to a patron saint. The guild windows of Chartres Cathedral are among the most vivid social documents of the medieval world. The butchers, the bakers, the money changers, the drapers, each guild depicted in the lower panels of its window in the act of the trade that had funded the glass above, their figures small and bustling and specific, surrounded by the tools and products of their craft, while above them the saints and scriptural scenes rise in their hieratic remoteness. The window was a social contract as well as a theological statement. The guild gave the glass gave the guild a permanent presence in the house of God, and the house of God gave the guild's piety visible and lasting form. When the windows were in place, and the scaffolding had been struck for the last time, the effect of the completed interior was, and remains, in the cathedrals that have survived with their original glazing intact, one of the most overwhelming sensory experiences that the human-built environment has ever produced. The light that entered those windows was not the light that had been outside them. It had been transformed in its passage through the glass, its spectrum altered by the colors of the metal oxides in the melt, its intensity modulated by the thickness of the glass and the density of the color. In the morning, the east windows blazed with the direct light of the rising sun, the reds and golds burning with a heat that was entirely visual, that produced no warmth but gave a powerful sense of warmth. In the afternoon, the west windows caught the declining sun, and the nave filled with a light that was cool and blue and violet. The temperature of the building's interior atmosphere changing with the changing quality of the light in a way that was not physical but psychological, felt in the emotions rather than on the skin. And at midday, when the sun was high and the direct light fell through the clear-story windows at a steep angle, the whole interior was suffused with a complex, colored, shifting luminosity that came from every direction at once, and cast shadows that went down to shadows, colored blue shadow, gold shadow, blue shadow, gullo, red shadow, red shadow, blood shadow, red shadow, belt, shesso, wet, colored, out, sad, shed, sow, and burk, our help, how, or French will, how it will, bow with, act, without sacrist, wicksuk, with wick up, with a hat, with a up, a half, the dad, get half, go, fuck, sat the fell, demes, was, with the bagas, the disgust, I'd first stir, boost the seemed to have been made visible in a way that ordinary air was not. This was what Suger had wanted, and what the long labor of building made possible. The light did not merely illuminate the building, it was, in the fullest sense, the building's content, the substance that the stone skeleton had been constructed to contain and to transform. All the labor of the quarrymen and the masons, the geometers and the glazers, the blacksmiths and the carpenters, had been directed toward this single end, a vessel for light, built of stone, in which the light was held and colored and transformed until it seemed no longer to be ordinary light at all, but something else, something for which the medieval theologians had a word, lux, the primal light of creation, the light that existed before the sun and the stars, the light that was, in the theology of the period, an attribute or an emanation of God himself. The glazers who set those windows were not making decorations. They were, according to their own understanding of what they were doing, making a kind of icon of the divine nature, a material representation of an immaterial reality, and the beauty of what they made was not incidental to this purpose, but identical with it. The window was beautiful because God was light, and light was beautiful, and beauty was a form of truth that the eye could grasp before the mind could follow. The brotherhood of craft. The men who built the cathedrals lived and worked in a world of strict hierarchy and fierce pride, of ancient custom and constant innovation, of competitive secrecy and surprising openness. And to understand the cathedrals fully, it is necessary to understand something of the human world in which they were produced, the world of the craftsmen themselves, the social and professional structures through which knowledge was transmitted and work was organized, and the extraordinary ambitions of bishops and kings were translated into the daily labor of thousands of ordinary men. This world is not easily visible to us. The craftsmen left few written records of their own, being for the most part illiterate in the Latin that was the language of record and of intellectual life, and the accounts and chronicles that document the buildings are largely silent about the individual men who made them, recording payments and quantities of material, but rarely the names or biographies of Biterales, of biographies of Bigralagus, or biacrogrogries, by biographies by your Morkragax of Backragax by God Bog, with his inward beard red big, with how capenman with wits will up with up with up and sour das with up by words masak work haka no effect das to this us the what the with that this got Yet we can reconstruct something of this world from the traces it left, in the mason's marks on the stone, in the building accounts where they survive, in the guild records and lodge ordinances, and the occasional theoretical text by a master builder who was learnt enough, and vain enough, to commit his knowledge to writing. At the summit of the entire enterprise stood the master builder, the magister operis, or, in later usage, the architect, though this word carried different resonances than it does today. The master builder was a man of unusual attainments, skilled in geometry and in the practical traditions of stone construction, experienced in the management of large and complex building operations, capable of translating a patron's aspirations into a buildable design and then of managing the construction of that design over a period that might span decades. He was also, necessarily, a man of some social standing, not a nobleman, in most cases, but a figure of sufficient dignity and authority to deal on relatively equal terms with bishops and cathedral chapters, to negotiate contracts and manage budgets and represent his own professional interests in dealings with powerful institutions, in dealings with powerful interests, in dealings with powerful interests, in its playful of powerfulness palthy in it, in its plesitska kunik sixabiops, get its up in its amid of it in raw or sicketipped whipsipmen with blout quick plap black up blocked la with the up la with luck up out bubble apples cack up go up have get about will of backrukas water put the verse the skiska for the status of the master builder rose significantly over the course of the 12th and 13th centuries as the scale and ambition of cathedral projects grew, and the professional demands placed on the men who directed them became more evident. By the late 13th century, a successful master builder might be a man of considerable wealth, owning property and employing subcontractors, his name recorded with some respect in the accounts, and occasionally, as in the famous memorial slab of Hugh Libigier, at Reims commemorated in stone with an effigy that placed him among the honored dead of the institution his work had placed him commemorated. Is placed to commemorate that is immersive epilus de subbub, perhaps to an sepsic band clerks lexic. A sepperf penepsiv cup ben with wickaprove kama bitsar the fell at but the master builder was not the whole story, and the tendency of later ages to focus on him, to seek a single creative genius behind the cathedral, analogous to the single artist behind a painting, misrepresents the fundamentally collective nature of the enterprise. Below the master builder, and essential to the realization of his designs, was a hierarchy of specialized craftsmen whose skills were as carefully cultivated and as jealously guarded as his own. The master masons, senior craftsmen, each responsible for a specific section of the building or a specific class of work, were the primary intermediaries between the master builder's vision and the working masons who executed it. They received the templates and instructions from the master builder, interpreted them in light of the specific conditions of their section of the work, and communicated them to the men below. They also possessed a sufficient understanding of geometry and structural principle to make decisions in the master builder's absence, to solve the small problems and resolve the local complications that arose continuously in the course of construction, without having to wait for the master to return from wherever else his responsibilities had taken him. The lodge was the social and professional unit within which this hierarchy operated, and it was something considerably more than a workplace. The lodge, a term that referred both to the physical structure, a long timber building erected at the edge of the building site to provide a covered workspace for the masons, and to the social institution of the organized group of craftsmen who worked together within it, was the basic cell of the building trades. In the lodge, the masons kept their tools and their templates. They dressed stone in the dry and the warm, cutting the final profiles and surfaces of blocks that would later be lifted into the building. They ate their meals together, and in winter, when the building season was suspended and the mortar could not be laid, they sometimes lived in the lodge as well, maintaining a continuous community of skilled workers who would be ready when building resumed in the spring. The lodge was a school in the oldest sense, a place where knowledge was transmitted by proximity and practice, where the apprentice learned by watching the journeyman and the journeyman by watching the master, where the standards of the trade were maintained not by written examination but by the continuous judgment of peers whose opinion mattered because it determined in the most direct way whether you were given work or turned away. The transmission of knowledge within the lodge was governed by a strict code of professional ethics and secrecy that had developed over many generations and that would eventually crystallize into the formal institutions of the medieval guild and, in a later and more elaborated form, into the ritual organizations of speculative Freemasonry. The essential principle was this: the knowledge of the craft, above all, The geometric knowledge that allowed the master to generate the forms of the building from a small number of initial measurements was not to be shared with those outside the craft, and was not to be transferred to those within the craft, except through the proper channels of apprenticeship and initiation. This secrecy was not mysticism, though it later acquired mystical overtones. It was professional self-protection, the reasonable desire of men who had invested years in acquiring difficult knowledge to prevent that knowledge from being appropriated by those who had not made the same investment. The apprentice who entered the lodge, usually as a boy of 12 or 14, bound to a master mason for a term of years, typically 7, began at the bottom of a long and demanding ladder. His first years were spent in unskilled labor, fetching and carrying, mixing mortar, operating the lifting mechanisms, learning the names and characteristics of the different types of stone, absorbing by continuous exposure the rhythms and habits of the working site. Gradually, as his hands grew stronger and his eye more practiced, he was introduced to the simpler operations of dressing stone, working a surface flat, cutting a simple chamfer, following a template to produce a standard molded profile. These operations were taught by demonstration and by correction, the master or journeyman standing beside the apprentice and guiding his hands, or taking the tool from him and showing with a few strokes of the chisel what was required, then returning it and watching as the boy attempted to replicate what he had seen. The standard of accuracy required was high. A molding that deviated from its template by more than a fraction of an inch would be rejected, and the apprentice would have to cut the stone again or face the loss of his day's pay. The journeyman who had completed his apprenticeship and received his freedom of the craft possessed enough skill to work competently on any standard building operation, but the highest knowledge, the geometric procedures by which the forms of a new design could be generated, the understanding of structural principles that allowed the master to design as well as to execute, was transmitted not in the early years of apprenticeship, but much later, to those men who had shown both the practical skill and the intellectual capacity that the role of master demanded. This higher knowledge was the true secret of the lodge, and the responsibility for its transmission was taken seriously. The records of the German lodges from the 14th and 15th centuries, among the most complete documents we have of the internal organization of the medieval building trades, describe elaborate procedures for the initiation of masters, including oaths of secrecy, rituals of admission, and the formal instruction in geometry that marked the transition from journeyman to master. These documents are the direct ancestors of the Masonic ritual that would develop in the 17th and 18th centuries, and they testify to the seriousness with which the craftsmen of the high medieval period regarded the knowledge they held. Yet the world of the craftsman was not only a world of secrecy and hierarchy, it was also a world of remarkable mobility and openness, at least within the profession itself. Master builders traveled widely, crossing political and linguistic boundaries in search of work and reputation. The building records of the great cathedrals show craftsmen originating from diverse regions working side by side. Normans in England, Flemish masons in France, French masters in Spain and Germany and the Holy Land. The spread of Gothic architecture across Europe was not merely a matter of visual influence, of one bishop seeing another's cathedral and wanting something similar for his own city. It was also, and more fundamentally, a matter of the movement of craftsmen who carried in their hands and their memories the practical knowledge of how to build in the Gothic manner. When the Archbishop of Canterbury commissioned the rebuilding of the choir of his cathedral after the fire of 1174, he imported a French master, William of Sens, who brought with him the technical knowledge of the French Gothic tradition and applied it to an English building, producing a structure that is at once distinctly English in some of its details and unmistakably French in its structural logic. The cathedral was an international institution, and the craft that served it was an international profession, by the movement of men whose skill was more portable than any other asset of the medieval economy. The long labor. A great cathedral took not years but centuries, and this fact, so simple to state, so difficult to hold in the imagination with any real comprehension of what it meant, is perhaps the most fundamental thing to understand about the building of the Gothic cathedrals. It was not merely that the construction of a large and complex building took a long time. It was that the time frame of a cathedral project exceeded, in most cases, the lifespan of any individual human being involved in it, often by a considerable multiple. The men who laid the first stone never lived to see the vault completed. The men who completed the vault had never known the men who laid the first stone. A cathedral was not built by a generation. It was built by a civilization, by the continuous, faithful effort of a people who believed, across many generations, that what they were doing mattered more than the duration of any individual life, and who sustained that belief through the ordinary difficulties of labor and poverty and plague and war and the perpetual shortage of money that afflicted every major building project from the first day of construction to the last. The practical implications of this timescale were profound. A building project that extended over 200 years, and Chartres, Notre Dame de Paris, Cologne, Salisbury, Wells, and many others took roughly that long, or longer. To reach their essential completed form was a project that passed through the hands of many master builders, each bringing his own training and his own aesthetic preferences and his own structural understanding to a building that already existed in part, whose forms had been determined by his predecessors, whose trajectory had been established before he arrived. To take over a cathedral in progress was to enter into a conversation with the dead, to read the building as a text, and to understand from it what the men who had worked on it before you had intended, where they had been leading, what problems they had left unsolved, what opportunities they had opened but not yet pursued. Some masters continued their predecessors' work faithfully, completing what had been begun with minimal deviation from the established design. Others modified and extended and improved as they went, introducing new elements that reflected the changes in style and structural understanding that had occurred in the decades since the building was begun, so that the completed cathedral was a palimpsest, a document written over and over by different hands, each layer visible to the trained eye, each layer a chapter in the building's long life. The funding of this extended enterprise was a permanent preoccupation of the cathedral chapter. The clergy who governed the institution and who bore the responsibility for ensuring that the money to build, and later to maintain and extend, the cathedral kept flowing. The sources of funding were multiple and varied: episcopal revenues, the tithes that flowed into the diocese, gifts from the local nobility, the offerings of pilgrims who came to venerate the relics housed in the cathedral, the proceeds of indulgences granted by the Pope to those who contributed to the building fund, legacies left in the wills of the devout, and the accumulated returns of the cathedral's own landed estates. None of these sources was reliable on its own, and the history of cathedral building is punctuated by periods of suspension, sometimes of months, sometimes of years, occasionally of decades, or sometimes of months, sometimes of years, occasionally of sactades, occasionis, Petra of a chapter of Kachapro, but chapter and equegerit, clack quack quack, it's quack quack quack, clack quack, ack quack qua, a clog, quack, ack, click, anka, gutabuff, witakwik with squillet with saf, without with cup, wick up to hop, where, cock, hoop, loop, load, pick, wick up, falca, upka, bet, quick, sauka, deck, pix, you what does wick up, work us, without well, go with the goes the school. A war had diverted resources and attention elsewhere. These interruptions left their mark on the buildings. A wall built in one campaign and then left for 20 years. Before the campaign above it was added, will often show a difference in the style of the carved details, or a slight change in the color of the stone, as the quarry that supplied the original material was exhausted and a new source was found, or a subtle shift in the proportional system as a new master builder introduced modifications to the design. These breaks are visible to the trained eye and have been used by architectural historians to reconstruct the building campaigns of the great cathedrals, to divide their histories into chapters, identifying which sections were built when and under whose direction, assembling from the evidence of the stone itself a narrative of construction that the written records, where they survive at all, only partially support. The plague of 1348 and 1349, the Black Death, which killed between a third and a half of the population of Europe in the space of less than 2 years, interrupted building campaigns across the continent with an abruptness that the building accounts record with terse, terrible simplicity. The payments stop, the lists of workers, careful and continuous for years, simply end, and then, after a gap of months or years, they begin again, with different names, fewer of them, sometimes at a significantly lower rate of pay, as the labor market convulsed in the aftermath of catastrophic mortality. The cathedrals that were under construction in 1348 bear the mark of the plague in the breaks in their masonry, in the changes of design that occurred when work resumed under new masters who had inherited a depleted profession. in the occasional abandonment of ambitious programs that had been planned before the disaster and that could not be resumed in a world that had lost the craftsmen and the economic confidence to carry them through. The towers of Cologne Cathedral, among the most ambitious Gothic designs ever conceived, were begun in the 13th century and then left uncompleted, a vast wooden crane standing above the unfinished stump of the South Tower for centuries, a monument to interrupted ambition until the 19th century, when the Romantic movement's enthusiasm for the Gothic past inspired a new campaign of construction that finally, in 1880, completed what the medieval builders had begun more than 600 years earlier. When a master builder died in mid-project, killed by a fall from the scaffold, as happened to William of Sens at Canterbury in 1178, who was carried down from the vault where he was working when the centering gave way, and who, gravely injured, had to be replaced by another master named William, an Englishman, who completed the choir in a form somewhat modified from his predecessor's design. The continuity of the project depended on the degree to which the dead man's intentions could be read from the work already done, and from whatever drawings or templates he had left behind. The building itself was the primary document. The proportions already established, the details already worked out in stone, the trajectory of the design already set. These provided the framework within which the new master had to work, whether he wished to or not. To deviate too radically from what was already built was to create an incoherence in the finished building that would be visible for centuries. To follow the dead man's intentions faithfully required understanding them, and understanding them required the kind of geometric literacy that could read a building as the expression of a proportional system and extrapolate from what had been built to what was still to come. This dependence of one generation's work upon the previous generation's decisions created a continuity that was one of the cathedral's most powerful qualities, a coherence of conception that extended across time in a way that no single human life could encompass. The builders of the nave of Chartres, working in the early 13th century, were working within constraints established by the builders of the crypt and the choir a generation earlier. The builders of the West Towers, working in the late 12th century in one case and the 16th in another, for the North Tower of Chartres was not completed until 1513, were working within constraints established by builders who had been dead for centuries. The cathedral was a form that the culture held in common, that belonged to no single generation. That was the collective property of all the generations that had contributed to it, and all the generations that would inherit it. To build it was to make a claim on the future, to insist that what was being done now would matter to people who had not yet been born, and to accept a corresponding obligation to honor the work of people who were now dead. It was, in the fullest sense of an often abused phrase, an act of civilization. 12. The cathedral complete. And then, one day, though no one day could truly bear such weight, no single moment could serve as the clean ending of a story that had accumulated over generations, like the rings of a great oak, it was finished. The word itself is inadequate. A cathedral is never entirely finished in the way that a chair or a barrel or a suit of clothes is finished. Never reduced to a state of absolute completion after which nothing remains to be done and the object can simply be used and admired. There were always repairs to make, always new chapels proposed by newly wealthy donors, always windows cracking under the frost and pinnacles loosening under the wind and sections of vault threatening to open at their joints as the invisible movements of the building's foundation played out over decades and centuries. The cathedral was a living thing in this sense, a thing in continuous, slow conversation with the forces acting upon it, always slightly changing, always being tended and maintained and extended and modified beneath its vaults. But there came a moment, or rather, a period, a decade or a generation, when the essential work was done. The last great campaign of construction had been completed. The last vault had been keyed. The last window had been glazed and set into its iron armatures. The last pinnacle had been lifted to its place above the flying buttress pier and set in its bed of mortar. The last gargoyle had been positioned on its parapet, that remarkable company of stone grotesques, those carved heads and creatures that projected from the walls of the completed cathedral on every side, their mouths open to receive the rainwater that the sloping roofs above them shed, conducting it away from the walls in a stream of water that fell to the ground clear of the masonry, and thus protected the joint between wall and roof from the slow dissolution that standing water would have caused. The gargoyles were functional. Every element of the cathedral was functional, in the sense that its presence served a purpose beyond the merely decorative. But the gargoyles were functional in a way that was also irrepressible. Their carved forms exuberantly, gleefully, sometimes shockingly expressive. their faces contorted into expressions that ranged from the comic to the genuinely monstrous. Their bodies, those of creatures that had no existence in the natural world but that seemed, in the imagination of the carvers, to belong perfectly to the world of a building that was itself something between the natural and the supernatural. The craftsmen who had done this work, the generation that happened to be present at the completion, did not experience it as a conclusion so much as an arrival at a state of sufficient completeness that the building could now fulfill its primary purpose, to be a place of worship, a home for the sacred liturgy, a space in which the community of the faithful could gather in the presence of something that was not entirely of this world. The bishop came for the consecration, or reconsecration, if sections of the building had been in use during the long construction, and now the whole was being formally dedicated. He walked in procession round the outside of the building and then through its doors, sprinkling holy water, praying the appointed prayers, performing the ancient rituals by which a building was set apart from ordinary use and given over to the divine. The candles were lit, hundreds of them, their collective light filling the interior with a warm, unsteady glow that was quite different from the cool, colored, directional light of the windows, and that created its own special quality of illumination in the nave. The light of human attention pays. The people who filled the building for this consecration came from every rank of the society that had built it. They included the bishops and canons and clergy who had overseen the project and prayed for its completion. They included the merchants and guild masters who had funded the windows and the chapels that bore their names. They included the lords and knights and their families whose ancestors had given land and money to the cathedral chapter over the generations. And they included the ordinary people of the city and the surrounding countryside, the artisans and laborers and farmers and merchants of every degree, the people in whose daily lives the cathedral had been a constant presence, an ever-changing spectacle at the heart of their city, a source of civic pride and sometimes civic anxiety, for the burden of funding so vast an enterprise was never borne lightly, and the disputes between cathedral chapters and city governments over building costs and clerical privileges were among the most contentious and enduring of medieval urban politics. These ordinary people, the men and women who had grown up in the shadow of the cathedral's scaffolding, who had seen it grow year by year as they went about their lives, who had sometimes worked on its construction, or had fathers or brothers who had perhaps never in their lives been inside a building larger than a modest parish church or a market hall. When they entered the completed cathedral for the first time, they encountered something for which nothing in their experience had prepared them. They had lived their entire lives in low rooms, houses of timber and daub, with ceilings that a tall man could almost touch, with windows that admitted grudging rectangles of grey northern light. The largest interior spaces they had ever entered, a great hall, a barn, a covered market, were spaces whose scale was comprehensible, whose ceiling was visible and countable, whose proportions were those of a box, elongated perhaps, but still essentially a box. The nave of a great Gothic cathedral was none of these things. Its ceiling was 60, 70, sometimes more than 100 feet above the floor, a height so far beyond ordinary experience that it did not register as a ceiling at all, at first, but as something else, something that the eye could not quite organize into a category. The vault ribs sprang from their piers and soared upward, and crossed each other, and converged at their keystones, and the eye followed them upward and arrived, after a long journey, at a surface that seemed less like a ceiling than like the underside of the sky, patterned and colored and colored and colored, acceding not forward and muckward, on a cussed board, attempted a casting mat, paps into mudband, casupsisins, gan ricasipsispin, oakum cups and bob, and with bopon, or harm, pop where bar with foings, deal with up, at our boys could. Would the how would have to put had ask would have bas for up the grab get with gas get this gas get a scatus castle was simply gave up measuring and settled into a different mode of attention. And the light in a great Gothic cathedral on a bright morning is unlike any other light that the human environment produces. It is colored, to begin with, not uniformly, not like the tinted light in a room with a colored curtain, but variously, complexly, with every color of the spectrum present simultaneously in different parts of the interior, shifting and changing as the sun moved and as the clouds passed before it. The floor was striped with long bands of colored light that moved slowly across the paving stones as the morning advanced. the red from the west windows of the south transept reaching across the nave in a band that contracted and expanded with the changing angle of the sun. The columns were touched with blue from the great west window, and the capitals of the piers were gilded by a slant of gold from a clerestory window to the south, and the faces of the congregation were coloured and recolored as they moved through the nave. Passing from one coloured zone to another, their ordinary flesh suddenly rendered extraordinary by the light, their ordinary flesh suddenly rendered ordinary. This was not naturally flattered, this was not an up, this was not knowest, this was us basser, it was at mapad, but with metad, with prap, written it with a batter before someone was with low with pap with hat, popper was with pepper, with the with was spack, west this it was transformed light that had been worked upon by human craft, that had passed through the hands and the imagination of the glazers, that carried in its altered spectrum the intentions of the men who had made the glass, and the women who had funded it, and the bishops who had determined what it should depict. It was, in the truest sense, a cultural product, not sunlight at all anymore, but something that had been made. The men and women who stood in that light on the day of the consecration were not, for the most part, theologically sophisticated. They did not know Pseudo-Dionysius or the theology of divine light. They did not understand the geometry of the vault above them, or the structural logic of the flying buttresses outside. What they felt was simpler and more powerful than any of this. They felt small, not in a humiliating way, but in the way that standing before the ocean or on the edge of a great mountain makes a person feel small. As a clarification, a sudden, accurate perception of scale that is accompanied not by distress, but by something closer to relief. The ordinary human world, its quarrels and its ambitions, its griefs and its petty urgencies receded. The space above was immense, and the light was extraordinary, and the singing of the choir, when it began, filled the space with a sound that seemed to come from everywhere at once, from the stone itself, as if the building was singing. And in this combination of experiences, the height, the light, the music, the smell of incense and stone and candle wax, the press of the crowd, and the individual privacy of each person's inward response to what surrounded them, the building fulfilled its purpose. Abbot Suger, who had begun it all, who had stood in the new choir of Saint-Denis in 1144 and tried to find words for what he felt, had used the language of mystical theology, the transportation from the inferior world to the higher world, the sense of dwelling in some strange region between earth and heaven. His language was Latin, and it was the language of a learned man, shaped by centuries of theological reflection on the nature of the divine. The farmer from the Beaussy who stood in the nave of Chartres on the day of its consecration had no such language. He had only the experience itself. But the experience, one may reasonably believe, was not entirely different from what Suger had described, because it was the same building, expressing the same intention, doing the same work upon the human senses and the human soul. The cathedral was a machine for a specific purpose, and the purpose was this: to make a person feel, for a moment, that the ordinary categories of earthly existence, the smallness of the self, the brevity of a life, the weight of grief and labor and mortality, had been, if not dissolved, then placed in a perspective so vast, of so luminous, that they could be borne. That, in the end, was what the centuries of labor had produced. Not merely a building, however magnificent, however technically extraordinary, not merely a monument, however enduring, however expressive of the culture that had built it, but a gift, a thing made by the living for the living, and for all the living that were yet to come, that offered, to anyone who entered it in the right spirit, or even in no particular spirit at all, simply as a human being standing in an extraordinary space, the possibility of a moment in which the world, as it ordinarily presented itself, gave way to something larger. The gargoyles spouted their water from the parapets, the wind sang through the tracery of the windows, the light moved across the ancient floor, changing its colors with the changing hour. The building stood, as it would stand for centuries more, its stone walls holding within them the invisible record of every hand that had shaped them, every life that had been given to their making, the quarrymen and the masons, the glazers and the carpenters, the master builders and the apprentices. the bishops who had prayed for it, and the merchants who had funded it, and the ordinary men and women who had simply lived in its shadow and been changed by it in ways they could not have named over the course of long and ordinary lives. The cathedral was complete, which is to say, it was ready to begin. There is a particular quality of silence inside a great Gothic cathedral in the early morning, before the first visitors arrive, before the sacristan has made his rounds with his ring of iron keys, before the candles are lit at the side altars and the organ wakes the cold air with its slow, authoritative harmonies. It is not the silence of emptiness, not the silence of a room that has been vacated and left behind. It is something altogether different and more charged, the silence of presence, of a space so saturated with accumulated human intention, with the layered devotion and labor of so many centuries and so many lives, that the absence of immediate human activity does not diminish it but deepens it, the way a great library is most itself, not when it is noisy and crowded, but when it is still and the books are simply there, waiting, holding their contents with the patient authority of things that have been waiting for a very long time and have learned that waiting is not a deprivation but a form of readiness. The cathedral in the cathedral, the cathedral, the cathedral, the cathedral in the cathedral of the cathedral, the cathedral of the cathedral, in the cathedral, the cathedral, so, in the caca, the clipperthipkin, kirto, kuited hiccup of it, swalas, plotut, with club, walk with the top with a box, ipraga, pump with the put, what put, kapapa, got it at house, muktabubata, with scar, hog, warf of carcass, fuck out effort, ask of best of love, because the cart, but that Smwed was ask purpose or stirred met It is ready. It has always been ready. It was built to be ready, to receive whatever human being came through its doors, in whatever state they arrived, burdened or lightened, faithful or doubting, broken or merely curious, and to offer them, without condition and without judgment, the experience of a space that was larger than ordinary life and older than any single sorrow. The stones, remember, this is not a metaphor, or not only a metaphor. The stones of a great Gothic cathedral hold within them, in the precise angle of every cut surface, in the curve of every arch soffit, in the exact profile of every moulding that runs along the base of every pier, the record of every decision ever made about this building, every problem solved and every impasse negotiated, every winter when the mortar froze and the work stopped and the walls were covered with straw against the frost, and every spring when the straw was pulled away and the tools were taken up again and the slow climb toward the sky resumed. The mason who cut that capital, the man who spent a week with his chisel working the stone foliage into the form that the template demanded, is gone so completely that not even his name survives in any record we have been able to find. But the capital is here. His chisel marks are here. Sometimes, where the paint that once covered everything has fallen away, and the bare stone speaks its plain testimony. A hand was here, a hand that knew what it was doing, a hand that worked with care. The stones do not remember in the way that a written record remembers. They cannot tell us the man's name or his age, or how long he spent on this particular piece, or whether he was content with what he had made. But they remember in the only way that finally matters. They hold the form his hands gave them, unchanged, through 8 centuries of frost and heat, and the slow chemical conversation between stone and atmosphere, and they will hold it, if we do not fail in our own obligation to maintain them, for 8 centuries more. What the cathedrals represent, and here we must speak with both care and courage, without the false sentiment that turns the past into a golden age it never was, but also without the false modesty that refuses to call great things great for fear of seeming naive, is one of the highest and most sustained achievements in the entire history of human making. This is not a claim about religion, though religion was the motivation. It is not a claim about the Middle Ages as a period superior to our own. For the men and women who built these buildings lived in conditions of poverty and hardship and injustice that we would not wish to restore. It is a claim about craft, and about what craft at its highest level, craft animated by a great shared purpose, sustained across generations, pushed always to its absolute limit by the combined pressure of theological ambition and competitive civic pride, is capable of producing. The cathedrals are extraordinary, not because they are old, though their age is part of what they are, and part of how they affect us. They are not extraordinary simply because they are large, though size was itself a form of argument in the medieval world. an assertion in stone about the scale and the dignity of what the building was built to honor. They are extraordinary, above all, because they were made by people who had so much less than we have, less technology, less mathematical formalism, less understanding of the science of materials and structures, less ability to model their designs before committing them to stone, and who nevertheless made more, in terms of beauty and structural ingenuity, and lasting expressive power and sheer emotional impact, than almost anything that their far better equipped successors in 5 centuries of further development have managed to equal. They were made without computers and without cranes, without the differential equations of structural analysis or the finite element models that a modern engineer would use to check the stability of a vault, without the safety regulations that govern modern construction sites, and that would have shut down every major medieval building operation within a week of inspection. They were made by men who worked entirely by hand, in cold and in heat, and in the persistent damp of northern European autumns, at heights that would make a modern safety officer blanch, for wages that were modest by the standards of any age, and in the service of an idea that most of the workers could not have articulated in any formal theological language, but that they understood, in the most immediate and bodily way, through the daily practice of their craft, and through the evidence of the building growing around them, that some things are worth making with everything you have, and worth making well, and worth making to last, even if you will not live to see them finished, and even if no one will remember your name when they are done. The 12 chapters of this chronicle have tried to follow the arc of that making, its full length and its full complexity. From the first visionary impulse in the mind of a small, ambitious, beauty-ravished abbot, standing in a dark and overcrowded church north of Paris, dreaming of walls that were made of light, through the long, patient, dangerous, technically demanding process by which that dream was translated, over many generations and many individual lives, into the stone and glass of the greatest buildings Europe has ever produced. We began with the vision, with Suger at Saint-Denis, with the theology of divine light that guided his ambitions and set the aesthetic program that all subsequent Gothic building would attempt to fulfill. We moved to the ground, to the master builder walking his proposed site for days, pressing his ear to the earth, reading in the soil the capacity for trustworthiness that the centuries would demand of it. We descended into the quarries, where the men who came before every other craftsman worked in darkness and smoke, tearing from the living rock the substance of the cathedrals, marking each stone with the personal symbol that was their only signature on a work too large for any individual name. We followed the master builder to his tracing house floor, where the geometry that governed everything was scratched into plaster with a metal point, where the great arcs and proportions of the building were worked out in full scale, before being handed down through templates of the working masons below. We watched the walls rise slowly, seasonally, constrained by the curing of the mortar and the coming of the frost. Each course a small increment of the immense whole. Each year's work a single ring in the stone tree that was slowly forming above the foundations. We understood the pointed arch, that modest geometric adjustment, whose consequences were so far-reaching that they transformed an entire civilization's built environment, that freed the vault from the tyranny of the semicircle, and with it freed the wall from the tyranny of structural obligation, making possible the impossible, a stone building whose walls had nearly ceased to exist. We traced the logic of the skeleton, the ribbed vault gathering the forces of the ceiling into lines, the clustered piers channeling those lines downward, the flying buttresses intercepting the lateral thrust and leaping with it, in their great arcing half-arches across the open air to the outer piers and the earth. We stood outside and looked at those flying buttresses in the full understanding of what they were doing, the forces of the building made visible, the structural logic displayed on the exterior with an honesty and a drama that was itself a form of beauty, and we noted the pinnacles above the outer piers, those tons of carved stone that were not decoration, that was those tons of carifs, those two stubbles, teela tulls, tons of cues tumbles to star, but darp spud, but ball, but cluxed, with plog a lap, blah, and with pib sign with ponnet, with small, ball, it will, and with sweat up wolf, wet up works, with gark, with sweat up, with hap, with that hat left, wick up whoop out, wick half walk, with full hap work, hat walk, go or but best boy, walk the gabble, how that does have but does the books with facility of pressing down upon the piers to anchor them against the lateral forces they were built to resist. Beautiful because the craftsmen who carved them could not conceive of making something purely functional, and ugly because beauty and utility had not yet been separated into the different categories that a later and more analytical age would assign them to. We entered the building to find the glaziers at work, assembling from hundreds of small pieces of pot metal glass colored in the furnace itself, with the oxides of copper and iron and cobalt and manganese, the great window, compositions that would transform the nave from a stone interior into a vessel of light. We watched the lead cames being fitted and soldered, the iron armatures being set into the stone, the panels being lifted one by one into the waiting openings of the tracery until the wall of glass was complete and the interior of the building changed its nature entirely, became something that had not existed before and that cannot be adequately described to someone who has not stood inside it, a space in which the light itself has been transformed, colored and directed and made strange, so that the air of the building seems to have been given a quality it does not possess outside, as if the interior atmosphere is a different substance from the air of the world around. It is a different subsphere of censure, is a different censure of denture. Intensa, ensit spencer sensa bay to bay to him, when secessegate. Bensa pipinsk sinsa bixink sepsis separins but whiprep whip bin risada ala prepare ep whip with up with sawis books whip math whip We entered the world of the craftsmen themselves, the lodge, the hierarchy from apprentice to journeyman to master, the transmission of geometric knowledge through demonstration and practice and the carefully guarded secrecy of professional initiation, the movement of master builders across political and linguistic boundaries, carrying in their hands the technical knowledge that spread the Gothic style across the whole of Latin Christendom. We attended to the long labor, the building campaigns that stretched across decades and interrupted by plague and war, and the perpetual shortage of money, the succession of masters each reading in the existing building the intentions of his predecessor and continuing or modifying as his own understanding and the changed circumstances of his time required. The extraordinary act of trust in the future that every generation of builders performed by adding their work to a structure they had not begun and would not complete, trusting with a faith that was itself a form of the faith. The building was built to express that those who came after them was built to express that those are busy with start that those can be it, but with though it dark sat, pokitak with it, bad it, with to but repeat with it pad, but kupit, then hoop with better for to tap up pad, where perfects with scats mix, but where but with that, but up hack or hack at kuplefa, miss papa, that what up, back the back, cackapur pest with that, us, what's better to use just oh god, this just sitting with school. And we were present, at the end, for the completion, the last gargoyle set on its parapet, the last window glazed, the doors opened, and the people entering for the first time to stand in the nave and discover, in the most physical and immediate way, what light and height and stone together could do to the human soul. All of this, all 12 movements of this chronicle, has been an attempt to honor the making, to insist that the cathedrals are not merely there to be admired, but to be understood, and that the understanding deepens rather than diminishes the admiration. The visitor who stands in the nave of Chartres and knows something of how the vault above them was constructed, who can see in the ribs spreading from there, peers the lines of force that the master builder understood and controlled with his compass and his rod, does not lose the sense of wonder that an ignorant visitor might feel. They gain a second layer of wonder on top of the first, a wonder not merely at the effect but at the means, at the fact that these forms were generated by human minds and executed by human hands using tools that a modern craftsman would find primitive, in conditions that a modern worker would find intolerable, across a time frame that no individual life could encompass. The cathedral earns its wonder at every level of understanding you bring to it. It rewards the eye before the mind has had time to engage. It rewards the mind when the mind begins to ask how, and it rewards something deeper than either eye or mind. some faculty that does not have a precise name, but that is recognizable in its effects, the faculty that responds to greatness, that knows it when it stands in the presence of it, that feels in the marrow of the bones the difference between a thing well made and a thing greatly made. The cathedrals are still there. Chartres stands above its town on the plain of the Beaucy, as it has stood for 800 years, its two mismatched spires visible from miles away across the flat agricultural landscape. Its exterior, a complex world of carved stone and flying buttresses and gargoyles and the accumulated grime of centuries and the equally accumulated repairs and restorations of centuries. Its interior on a bright morning in June, a world of colored light of such intensity and beauty that people who have spent their entire lives in secular indifference to religious buildings stop walking and simply stand, arrested, somewhere in the nave, looking upward at the windows with expressions on their faces that they would be embarrassed to describe if anyone asked them what they were feeling. Notre-Dame de Paris, damaged by fire in 2019, and now in the process of a restoration that has been conducted with the care and the historical seriousness that the building demands, will stand again. Amiens stands, its nave, the tallest Gothic interior in France, its west facade, a carved encyclopedia of medieval theology, its choir stalls some of the greatest woodcarving the Middle Ages produced. Reims stands, where the kings of France were crowned for 1,000 years. Its west facade, three great portals surmounted by ranks of carved figures that have been looking out over the plain of Champagne since the 13th century, and that will be looking out, if we are faithful in our stewardship, long after everyone now living has joined the master builders in whatever silence follows, a life of work, and as well as filets. Literally silence follows. For a siphon with silence, so silence, bennett, with R on, in with brock, up, inside, or bar, but ha, what I've cough of black at the caffet, coffel of glow, costa the spit out, gog of scholars about wood worst, fouts, Salisbury stands, and Wells, and Lincoln, and the choir of Canterbury, where William of Sens began the English Gothic tradition in 1175, and where William the Englishman completed it after his predecessor's fall. Cologne stands, completed at last in 1880, but built throughout in the forms and the spirit of the medieval design that had been begun 6 centuries earlier. An act of cultural fidelity, so sustained and so serious that it is itself a kind of monument to the power that the Gothic tradition exercised over the European imagination, long after the faith that created it had been complicated and challenged and in many quarters abandoned. They are open in the morning. Most of them are free to enter, or nearly so. They require nothing of the visitor except the willingness to walk through the door and to stand inside for long enough to let the building do what it was built to do. The doing takes time. The cathedrals are not buildings that yield their full gift in the time it takes to walk through them with a guidebook and a camera. They require a kind of attention that is itself somewhat old-fashioned, patient, unoccupied, willing to simply be in a place without extracting information from it or producing content about it, willing to look upward and keep looking, willing to sit in one of the old wooden chairs in the nave and let 20 minutes pass in which nothing in particular happens except the slow shifting of the colored light across the stone floor and the distant sound of the city outside and the nearer sound of one's own breathing in a space that seems to give breathing a different quality, deeper, slower, as if the lungs know they are in a place where they are not required to be efficient. Go and stand in them, when you can. Take someone who has never been. Watch their face when they walk through the door and look up for the first time. Notice what happens to their expression, the brief involuntary suspension of the ordinary social mask, the moment before they have collected themselves enough to have an opinion or make a comment, when they are simply responding, without mediation, to what is in front of them and above them. That moment, that unguarded second of pure response to a space that is larger and older and more beautiful than anything ordinary life prepares us for, is the cathedral still doing its work, 8 centuries after the last stone was set, still fulfilling the purpose for which all those generations of builders gave their strength and their skill and, not infrequently, their lives. It is working on you, as it worked on the farmer from the Beaucy, who stood in the nave of Chartres on the day of its consecration. It is offering you what it has always offered, the gift of a moment outside the ordinary scale of things, a moment in which the world is briefly larger than your worries, and the light is extraordinary. and the stone above you holds, as it has always held, as it will go on holding long after you have gone. Good night, traveler. You have come a long way today through stone and centuries, through the smoke of quarries and the cold of scaffold-hung mornings, through the geometric dreams scratched in plaster and the colored glass assembled piece by patient piece in the low light of the glazer's workshop. You have walked the nave of every cathedral this chronicle has tried to conjure, felt the vault ribs spring above you and the colored light move across your hands, and heard, in the silence of the early morning, that deep and particular stillness that is the sound of 800 years of human faith held in suspension between four walls and a sky of stone. You are tired, perhaps, as all travelers are tired, who have walked far through territory that demanded attention and gave generously in return. Rest now. Let the images settle, the gargoyles on their parapets, the glazer's iron scoring the colored glass, the master builder on his knees in the soil of the chosen ground, listening for what only he could hear. Let the names of the craftsmen who left no names drift down through the dark like mortar dust, settling after a day's work, and know that their namelessness is not a tragedy, but simply the condition of most human labor, unnamed, unrecorded, present only in what it made, which in this case happens to be among the most beautiful things the world contains. The windows are dark now, the colored glass holding its colors in reserve, until the morning light comes to release them again. The vaults are quiet. The stones are keeping whatever they keep through the long night, the memory of the hands that shaped them, the warmth of the days they have stored across the centuries, the slow and imperceptible conversation they are always having with the forces of gravity and time, the conversation that will continue long after the last human voice has said its last word in the nave below. Sleep well and dreamfully, and when you wake, if there is a cathedral within reach, go and stand in it before the crowd arrives. Go and stand in it before the long history, and let eerily light, and be still for the long when they're long, and let it remand in, and let it wander lang you and lang you from in, and let that kin with them with sins, and that sin, and when they with me sin with her, kin with their sin with wisan with wick, willy, with work him, with hard. With where how is it? With how is that was a scop whistle with soft with whistle with the we was good what would wake up with that if with that with bow with what how wow ask with go well go skacks both was the more what goes second the carcass for if it was there are these buildings, still standing, still holding their light, still waiting for you, still saying, in the only language stone knows how to speak, we were here, and we made this, and we made it for you.